Hello everyone, welcome to BYJU'S exam prep. Welcome to your a wonderful session in our one shot series. So tell me who has joined the session. So I hope everybody is doing very well, guys, and today's session is going to be a very important session for you because only a few days are left for your gate examination, and in this particular time limit you have to revise your concept very well. And in this particular revision we are here with you, and as you know that one shot series is going on our channel, in which Rakesh sir, Sanjay sir has already taken a few subjects. Now today I am going to take a subject of network theory. And yes, but network theory is one of the most important subject for you, whether you are from electrical branch or from electronics branch, IN branch. This subject is very important. Okay. So good morning to everyone. Good morning Sai Kiran, Niku, Megan, Bhadur Prakash, Sagnika, Priyanka, and good morning Reshmo or Reshma to plan. Sorry if I am getting a wrong pronunciation. So are you ready? Are you ready for this session? Because this session is going to be a long session and I want everybody to be ready, and you have to take a breakfast. I hope that you have taken a breakfast and everything else. Okay. Good morning, Jaswant. Right. So what's going to be our this in this session? Let me quickly tell you. In this session, we are going to do theory as well as numerical. Okay. I know that in case of a theory you will see, sir, ye mujhe aata hai, but let be with me, because we are going to understand everything from a basic to advanced level and also solving questions over it. And yes, transient also. So I will tell you a shortcut way to solve the question of transient also. So let's start our today's session. But before that, share the session among your friends so that more and more students can join the session and we can also motivate from there. Let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience. I'm Tech Gold Medalist from NIT Allahabad, 7 times GATE qualified, and these are my area of expertise. And one more thing, tomorrow for the electrical students, I'm going to take session on power system. Okay, so start kare. So as you know that our particular marathon session is going on, in which we 4 faculties are taking the sessions one by one. Phases concept, हाँ सब होंगे चिंता मत करो बेटा, सब समझाएंगे एक एक करके. मैं आपको एक let me tell you the one brief कि what's going to be our plan. First we are going to learn about basics, then we are going to learn about KVL and KCL and all the laws, mesh law, nodal analysis and everything. Then we are going to learn about the sinusoidal analysis, or you can say a steady state. Then we are going to see a transient analysis. And in the end we are going to see the two-port network also. Okay, so everything is going to be planned accordingly. So just be with me and we will see everything here. Okay, so let's start with the most basic concept. What is current? Let's start with the most basic concept. What is charge? Charge is nothing but it's an electrical property of an atomic material which can present everywhere. Now we are not going to waste our time in a very small topic like charge, current and the voltage. Just a few basic points that you need to understand here. First of all, what is the current? Current is the flow of charge. Now this is the first equation you learn whenever you start preparation for your exam, which is I equal to dq by dt. This equation is very important, bacho, because if you see the previous year paper, many times the question has been asked over this. So we have given I is equal to dq by dt, which is the definition of current, which is the rate of change of charge measured in ampere. Now from this equation, I can also find out the charge. Charge is equal to integration of current with respect to time from 0 to t plus q0 plus. What is the q0 plus? Q0 plus is the initial charge stored in device. What is q0 plus? It is the initial charge. Stored in a device. For example, as you know, capacitors store the charges, or we have a different devices also. So we have an initial charge also present. So these two equations are very important. We will see one or two questions over this. But remember, whenever you are solving the question of charges through the current, this particular term you need to keep in your mind, that is the stored charges initially, right? Now what is the voltage? If you talk about the voltage here, let me see. What is the voltage? The voltage between 2 points are given by the simple concept, the particular electrical charge with respect to work done, है ना? So what is the voltage AV? It is dW by dQ. Now what we can do here? dW by dt is multiplied by dt by, इसको ऐसा करो. Let me take look one point. Remove this. So we know the voltage is equal to change of work done with respect to charges. Again, a very, very important formula, because as you know, the current and the voltage both depend on charges. So this formula is also very important. Wait a sec. This formula is also very important. Okay. Any doubt till here? देखो, meanwhile कोई भी doubt होगा मुझसे पूछ लेना. And we are going to solve both theory and questions. So be with me. Hello Ashok. Hello Vardhan. Okay, good. Now next point here. What is power? The simple definition of power, which is a general formula of a power. General formula of power is equal to V multiplied by I. Now this formula is very, very important, bachcho, because when you have a device in which you don't know what are the elements present. For example, I'm giving you some black box. Okay, black box, and I'm telling you that here the voltage is equal to 2 e raised to power minus t, and the current enters here is equal to 4 e raised to power minus 6t. For example, this thing. Now, if I'm asking how much power is absorbed here, then what is going to be the answer? The simple concept of P is equal to V multiplied by I. So this formula is very, very important, and it is universally applicable everywhere. Whether you are using a AC device or you are using a DC device, this formula is very, very important. That power is equal to V multiplied by I. In starting, we are talking about DC. After some time, we'll talk about AC also. So power is equal to V multiplied by I. Now tell me one point. Do you know about the sign convention? Do you know about how we can determine whether the power is absorbing or power is delivering? Comment section batao, everybody. So let me talk about the sign convention here. Wait a sec. Let me talk about the sign convention here. Before that. Wait a sec, bachcho. Wait a sec. Let me talk about the sign convention here. So power is equal to V multiplied by I. Now for the power, always remember we have two types of power. Power delivered and power absorbed. Now in a power absorbed, we have two types of power. The one is power stored and the one is power dissipation. Now the power dissipation means conversion of one form of energy into another form. For example, if you talk about the resistor dissipates the power. It means it converts the electrical energy into a heat energy. Whereas if you talk about the inductor and capacitor, that actually stores the power. Okay. Now the sign convention is a very, very important conversion to understand whether the power is absorbing or delivering. Hello everyone. Hello Rajesh. Okay. So I can see some comments here. So there is a basic rule here that you need to remember, bachcho. For any device, you need to remember, if the current enters at a positive terminal, it means power absorbed. It means a power is absorbed. A very, very important thing. If the current enters the positive terminal, it means the power absorbed. And if the current leaves the positive terminal, it means the power delivered. But my question is this enough to identify whether a device is delivering and absorbing power? My question is, just this information is enough to determine whether your power is absorbing or delivering? Yes or no? Tell me this point. क्या ये information काफी है? Yes or no? Tell me quickly. The answer is no. This information is not enough, bachcho. This information is not enough. You have to find out the power also. For example, let me ask you one simple question. Here. I have given a voltage 4 volt and the current is equal to minus 3 ampere. Okay. And this is my device. In which this is the voltage and this is the current I. So tell me, bachcho, whether the power is absorbing or delivering. In this case, tell me, the power is absorbing or delivering. Tell me, here, the power is absorbing or delivering. Think about it, deliver. But अभी आपने बोला कि this particular point is enough to identify that power is absorbed. Then why you are saying power is delivering? है ना? That's why always remember this point. This is not a complete information. This gives you the half information. You have to find out the power and you have to check the sign also. Okay? So always remember, if the direction of current and the voltage is given, first find out the power also. The first information is enough to identify whether you have to assume it absorption or delivering. Okay? So here, if you find out the power, it comes out to V multiplied by I. So 4 multiplied by minus 3, it comes out to be minus 12 volt. So since here we can see that power is absorbing, but because of negative sign, we have to say power delivered. Because of a negative sign, we have to say power delivered. Okay, this particular point is very, very strong. अभी तो आपको दिख रहा होगा सर ये तो बड़ा सिंपल था. We can change the direction of current and we got the answer. But when you solve the question based on power, this point is very, very important, बच्चों. Okay? 12 watt. My fault. Correct. 12 watt. Now, let's solve this question. Let's try to solve this question. Easy. This is a 1 mark question. Not only 2 marks, you also have to be good in a 1 mark question, bachcho. So try to solve this question. An energy source force a constant current of 2 ampere for 10 seconds flows through a light bulb. If 2.3 kilojoule is given off in the form of light and heat energy, calculate the voltage drop across the bulb. Try करो उसको बच्चों. Everybody try it. कैसे solve करोगे? Tell me. How will you solve this question? Think about it. Simple है. Basic question है. Basic question we have. An energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. If 2.3 kilojoule is given off in the form of light and heat energy, calculate the voltage drop. So voltage drop is how much? Voltage drop is equal to work done divided by charge. Voltage drop is equal to work done divided by charge. Now here, how much is the work done? Work done is 2.3 into 10 is to power 3. The charge is equal to 2 multiplied by 10. So is this will give you the answer? I square RT. We don't need to find out the heat energy, na? Because we don't know the resistance here. Then how will you find out the heat energy? Tell me, Ashok. है ना? So 115 volt. Check the calculation. है ना? Got it? Good. Now next question. Important. This one is important question. And बच्चों क्या कर रहे हो? सेशन को शेयर करो. Share the session among your friends, guys. If I remember, in Rakesh sir class, there is more than 100 students. What you are doing? Share the session among your friends. Right? This is going to be an important class. Ashok, that's a very good question. You said that you have know the I and E, but bacha, do you know the particular system only contain a resistor? It may contain a combination of resistor inductor. It may contain other combination. We don't know what is containing in a device. So we cannot say directly that it will be I square RT. It may be a non-linear device. It may be a non-linear resistor. Then the Ohm's law will not applicable and I square RT is not the answer there. Okay. PDF मिले बेटा PDF मिल जाएगा. That I have to check. Okay. कि उसमें जो मैंने लिखा है वो मिलेगा या नहीं. But if you want the blank PDF, that will be available. Okay, try करो. Question क्या है? The current IT sketch in a figure flows through the element. The charge at t equal to 5 microsecond will be. So they are asking what is the charge at t equal to 5 microsecond. It means this is the instant at which I need to find out the charge. Now I know the formula of charge. charge is equal to 0 to t integration of it dt plus the initial charge. Since no information is given about the initial charge, so obviously q0 plus is going to be 0. Now we have to integrate. To find out the charge at 5 microsecond, I have to integrate the current from 0 to 5. From 0 to 5. Now it's very easy. The integration of current with respect to time, you have to find out this area. Now how you can find out the area? Let me show you how you will find out the area. This is triangle. Okay, bachcho. And here you can see we have a trapezium. So this is a figure 1. This is a figure 2. So I can say Q is equal to area of figure 1. So half base. Base कितना है? 2. Height कितने यहाँ पे? 4. Plus half. What is the area of a trapezium? Do you know what is the area of trapezium? Think about it. Do you know what is the area of trapezium? Half into sum of parallel side. Parallel side is 4 plus 2. 4 plus 2 multiplied by the distance between them. What is the distance here? 5 minus 2, 3. Okay. So it comes out to be 4 plus 3 is 9. 13. Now unit is, this is in milli and micro. Sorry, this is in microsecond. So 10 is to power minus 6 and minus 3. 13 nanocoulomb. So one student has given the right answer. My world. नाम तो बड़ा अच्छा लगा हुआ है. तो 13 nanocoulomb. Okay, correct. Ashok has given the right answer. Venkat has given the right answer. Well done. Simple enough. And this is nothing but one of the previous year exam. This question has been asked. So you can see we haven't started the network theory till now, but 2 or 3 questions has been asked from the very basic concepts. That's why never forget that in a network theory you can't skip anything, because it is a basic subject. Also, it make the basics for other subject also. Okay? Now we'll talk about the different type of element like active element and passive element. So many things you know about the active and passive element. For example, what is an active element? Active element is a device which delivers the power. Passive element is a device which stores the power or which absorbs the power basically. Now my question is capacitor is an active device? Yes or no? Sorry. क्या capacitor active device है? Is capacitor a active device because it delivers the power? Simple question है. Is capacitor a active device? Think about it. Active devices are those which delivers the power. The answer is no. Why? Because always remember that particular point that it delivers the power is the half point. The full point is it must deliver the power for a large amount of time. In a capacitor, what happens when it delivers the power, then it delivers for the less amount of time. For example, microsecond, milliseconds. That's why the capacitor is a passive device. Remember this point carefully. Now, if you talk about graphically, in an active device, let me tell you, in an active device, the slope is negative, whereas in passive device, the slope is positive. What is the slope? Slope between the voltage and current. For example, here you can see, I have drawn one particular VI characteristic here. Here you can see what is the slope. Here, wait a sec. Here you can see, the black pen दिख रहा होगा ना? Wait a sec, let me change the color of a pen. Here you can see the slope is positive. Here you can see the slope is positive. Since the slope is positive, it is nothing but a passive device characteristic. Understand this point? Now tell me about this one. Okay, I will draw here. Tell me about this one. I hope everybody can see. Tell me about this one. Is this particular VI characteristic represents an active device or passive device? It represents active device or passive device. Good morning, Vinay. This particular VI characteristic here represent active device or passive device. Think about it quickly. See very carefully. Here the slope here, the slope is negative. Here, the slope is positive. So if the slope is negative for any time interval, if the slope is negative for a small particular instant, then the particular device is always active. Remember, active. For a passive device, the slope must be positive throughout the curve. Slope must be positive throughout the curve. But for the active device, if the slope is negative for a small amount of curve also, that will be an active device. Okay, that's a very, very important point you need to understand here. That in case of passive element, slope is positive throughout the characteristic. Whereas in active device, slope can be positive for a small amount, for a small instant, but it should be a negative there. Understand? So Shrivardhanam, Purni, I hope you understand this point, and Ashok also, that this is the characteristic of active device. Now next is bilateral and unilateral device. Krishna, I will cover everything, bacha, from the theorems, from the resonance, or if you talk about the phasors and all, I will cover everything. Okay. Now if you talk about bilateral and unilateral, bilateral devices are those devices which allows the current to flow in both directions. For example, resistor. The current can flow in this direction. A current can also flow in reverse direction. Whereas unilateral devices are those devices which allows the current to flow in a single direction only. For example, we have a diode. For example, we have an SCR. So these are the unilateral device which allows to flow the current only in one direction. Whereas resistor, inductor, capacitor are the bilateral devices. Now this is the simple definition everybody knows. Now if you talk about according to a characteristic, what is a bilateral device? It is a mirror image with respect to origin. It will have a mirror image with respect to origin. For example, this is the VI characteristic. You can see it very clearly that this VI characteristic is a mirror image with respect to the origin. It's a mirror image with respect to origin. So this is nothing but a bilateral device. Understood this point? Now let's draw one more characteristic. For example, this one. This is a VI characteristic. As you can see, that characteristic is not mirror image with respect to origin. So it means this is nothing but a unilateral device. Okay. So this particular graphical representation you need to remember. For a bilateral device, the particular characteristic must be mirror image with respect to origin. But in case of unilateral, you can draw any characteristic, right? Next, linear and non-linear. Very, very simple. Linear devices are those devices which follows the Ohm's law. Non-linear are those devices which does not follow the Ohm's law. That's why if you talk about the linear characteristic is a characteristic in which the curve must pass through origin. Just forget this thing. Okay, what is linear? The curve must pass through origin and have constant slope इसका मतलब क्या है? It means the slope will not change throughout the characteristic. The slope must be same and the particular characteristic must pass through the origin. For example, this is the VI characteristic here. Here you can see the slope is uniform. The slope is same throughout it. The slope is same here. Also, one more point very important, that it is passing through origin. That's why it forms a linear device. Now superposition follows. Beta Venkat, the opposite is true. It means if you have a linear device, then it follows the superposition principle. Okay. It is not true that if it is a superposition principle, then it follows the linear device. Okay. Both are the different statements. Okay. So let me ask you one question here. Let me see one point. Let me ask one question here. I am going to draw a VI characteristic. You have to identify which type of device we have. Okay. I am going to draw VI characteristic here. This is V. This is I. Tell me, active, passive, bilateral, unilateral, linear, non-linear. Tell me about this. Active, passive, bilateral, unilateral, linear, non-linear. This is the VI characteristic. This is a VI characteristic, and this question has been asked in a sample paper provided by the GATE authority. If I remember, so 2 or 3 years back. Unilateral, passive, non-linear. Okay. But you can get more than 6 marks if you know the concept very well initially. Okay, because right now we are revising the concept. So from the revision concept, one more thing I will tell you. Just not only this revision, after the class ends, you should go to our app. I will show you the QR code and follow the quiz. You have to attempt that quiz so that you can understand how much you have learned from the marathon session. So after the class, I will show you the QR code. You can scan it, the QR code, and go to the particular quiz section. Bilateral, active, linear. Okay, I am getting a different answer. Let's see very carefully. Bacha. First of all, it is a unilateral. Why it is a unilateral? See very carefully. This is not a mirror image. The saturation start at 5. The saturation start at -4. It means the length of this particular characteristic is smaller than the upper one. So it is not a mirror image. So unilateral device. It is non-linear. Why? Because the slope is not constant throughout the characteristic. Finally, it is a passive device. Okay. Sir, share in chat box. But what should this is a QR code. We have a QR code now. We have QR code. You can scan it. QR code cannot be shared in a chat box now. So it is a non-linear, unilateral, and a passive device. So I hope जिन बच्चों ने bilateral बोला, they understood this concept that it is not a bilateral because it is not a mirror image. Understood? Now one more. Here we can do one more. Okay, one more. Talk about this. Now tell me about this. Again, 3 options. Unilateral, bilateral, passive, active, linear, non-linear. Tell me about this. Think about it. And session ko share the session among your friends. Non-linear. Okay, passive, unilateral. Meghna said this particular point. Absolutely correct, bacho. It's a non-linear. The main point here is non-linearity. It is non-linear. Why it is non-linear? I told you for a linear, the characteristic must be uniform throughout the curve. The particular slope must be same throughout the curve. But here you can see there from here the slope is 0. At this point slope is 0. At this point slope is not equal to 0. So in this characteristic, the slope is changed. That's why it is a non-linear characteristic. Remember. And again, it is a passive, or you can say it is a unilateral. है ना? Simple हो गया? Passive and a unilateral. Any doubt here? For those who are saying the linear characteristic, always remember for a linear, the particular curve will have a same slope throughout its run. Let's talk about it. Okay. Now one more question. Let me ask you one more. है ना? Wait a sec, बच्चों. Let me ask you one more here. See very carefully. So we have given a device such that the polarity of voltage and the current I is given. And the characteristic of that device is also given. We have to identify whether it is an active device or a passive device. Think about it. कैसे होगा ये? Active and passive. Sir, you can use your palm. No, beta, that is not option on this particular board. I know there is some board where I can use the palm. Active. See, if it is active, then why from this particular characteristic, I can, with this particular polarity, I can say that it is a passive. Think about it. Active or passive? Absolutely correct. Absolutely correct. But I'm talking about only active. Kiran, talking about only active. Correct. It is active. Correct. It is an active. It is an active device. Very, very well done. Very, very well done. Why you have to identify? How you can identify in this manner? Remember, listen very carefully. If you have the polarity and current direction given, as well as the characteristic is given. So first of all, from the current direction polarity, you have to assume what is happening. If you see very carefully, here the power is absorbing, but this we are assuming. Now, once you have assumed it, now go to the characteristic and see the sign of power. See the sign of power. Here, the power is positive. Here, the power is negative. Since the power is negative at one of the region, it means it will supply the power for that particular region. That's why it is an active device. Okay. For example, let me ask you one more thing. Okay, we have a same device. Now the characteristic is this. We have a same device with this characteristic. Now tell me, active or passive? This is the same device. Now the characteristic is this one. So you have to identify active or passive. Active. Okay. Passive. Kiran said passive. Okay. Everybody think about it. Active or passive? Active. Let's see. First of all, from this particular thing, we can assume that power is absorbing. Now see the sign of power here. Here the power is negative. Here also the power is negative, because voltage is positive, current is negative. Since the power is negative, you have assumed it absorbing. So basically it is delivering the power. It means it is delivering the power, because you have assumed that power is absorbing, but from the characteristic you can say we have a negative side here. Correct. Everything correct. Negative, active, correct. Think. Okay, so this is the basic that we have learned about the different type of devices. Now the next point is about a resistor. So everybody knows what is resistor. We don't need to understand that much a lot here, but the few points you need to understand. According to Ohm's law, V is equal to IR. This is according to the Ohm's law. So tell me, this is the only statement for a Ohm's law, or other statements are also possible? If this is the only mathematical representation of a Ohm's law, or there are other mathematical representation also? So we, according to Ohm's law, we have V is equal to IR. Now here's the one point here. The heat energy dissipates by resistor is equal to I square RT. Heat energy dissipated by resistor is equal to I square RT. Now, again my question is, the heat energy, is this the instantaneous energy? Or is this the total heat energy dissipated by resistor? Tell me. Think about it. And try to give the answer with me. Now, if you talk about the power formula, always remember, if you talk about the power formula, you can use energy with respect to time. This formula we can use to find out the power, energy with respect to time. Is this correct? Total energy or instantaneous energy? Think about it. Total energy or instantaneous energy? Instant, total. बताओ आपको इसी में confusion है. ठीक है? Some are saying instant, some are saying total. It's a total energy that will dissipate it till time t. It's the total energy that dissipates till time t. Why? Because the energy formula is given by integration of power with respect to time. And we use the different time intervals here from t1 to t2. So this is the total energy dissipate between two time interval. Okay, remember this thing. Sir, the VI curve is active device. Last one, this one, if you talk about this one, this is for the active, because it is delivering the power now. So that's why it is for the active. Okay. Now next. Now if you talk about a capacitor is the one device which stores the charges. Okay. But there is a one point you need to understand here. This is the capacitor here. है ना? The current is entering plus minus V. So here I will be equal to C dV by dt. Okay, but if the capacitor is discharging, then I is equal to minus C dV by dt. This point is very important. This sign convention is a very important, bacho, that if the capacitor is absorbing, at that time current is equal to C dV by dt. If the particular capacitor is in discharging mode, then the current will be the minus C dV by dt. Okay, so understand this point. This is a very important point. You need to take care in your examination. Now if you talk about the capacitor, simple as there are a few properties. Capacitor, the current in capacitor is zero if the voltage across it is constant. That means capacitor acts as an open circuit. To understand this line again, if you have a DC supply, only, then capacitor will act like an open circuit. Okay, if you have a transient, means if you have a switch plus a DC supply, then what you have to do, then you cannot take the capacitor as an open device. Okay, so remember, only for the steady state and only for the DC, you have a capacitor act like an open circuit. Understood? Now again, this is very important. A small change in voltage does not occur across the capacitor, because think about it, if for a small time, if a voltage will change, then the current will tends to infinite, which is not possible. So for this is very important. For a small time interval, the voltage across the capacitor remains constant. Okay, once a steady state act like a that we will discuss in transient. Okay, now again, one question for you. Energy stored in capacitor is half CV square. Now tell me, is this the instantaneous energy or the total energy? Think about it. This formula, half CV square, very important. Is this the instantaneous energy or the total energy? Total, है ना? I know. Instantaneous. Very important point. Most of the students will wrong in this particular point. The formula half CV square, for the inductor half Li square. These are the instantaneous energy. It means it will tell you the energy at that particular instant. It is not telling you the total energy. Okay, think about it. It's a very important point. है ना? Meghna and Purmi and Manaswini and Reshma Tubalam. This is the instantaneous energy. Okay, understood? Now there are few points you know about a capacitor. That capacitor stores a finite amount of energy. If current through it is zero. Now let me ask you one question here. Quickly. Okay. Find the energy stored. Solve this question. Find energy stored. Okay. Let me check if I have done it correctly. Find the energy stored here. Think about it. Solve it. Manaswini, half CV square, the formula I gave you. That particular formula, if you use it in a DC, because in DC what happened, the voltage remain constant. For a DC, if you talk about instantaneous, if you talk about RMS, if you talk about total, if you talk about average, everything is same in case of DC. Nothing is different. But if you talk about in an AC circuit, we have a RMS is different, average different, instantaneous is different. So half CV square, which is the general formula of a stored energy, remember that is for the instantaneous. If you talk about in a DC case, you can say it's a total energy because it's remain constant. Manaswini is also correct through mathematical concept. I told you theoretically. Now try to solve this question. Simple. You have to find out the energy stored here. You have to find out the energy stored here. You have to find out the energy stored here. कैसे करोगे? See, whenever you see the DC supply, what you have to do? You have to open circuit the capacitor. This is the important point. Whenever you see that DC supply without switch, there is no switching here. So you can open this particular capacitor. So if you open this particular capacitor, I can open this capacitor. I can open this capacitor like this. Then I can calculate the voltage across it. Can I calculate the voltage across it? कैसे? I can calculate the voltage across it. Apply the KVL. It will be -4 plus 2 multiplied by 1 plus V plus 2 multiplied by 1 equal to 0. Here the V comes out to be 0. So the energy stored here is half CV square, which is also 0. So absolutely correct. It comes out to be 0. 3.2 कहां से आ रहा है? 3.2 कहां से आ रहा है? Tell me where you are getting a 3.2. है ना? तो energy stored here is 0. Right? Simple. Now let's talk about inductor. What is inductor, बच्चों? What is inductor? Can you tell me? Acha, one more point. I asked you one question before. That is the Ohm's law is enough that V is equal to IR. क्या यही सिर्फ Ohm's law होता है? Or is there any other mathematical equations also? Think about it. For a particular capacitor, we have charge directly proportional to voltage, and this is the second form of Ohm's law. Remember, this is the second form of Ohm's law. Okay, this is important point. Now, in case of inductor, what happened? The particular flux linkage, is directly proportional to current. So for devices in which the flux linkage is directly proportional to current, those are the linear inductor. So this particular characteristic will tell you the linear inductor. Important. Linear inductor. In your course, if you talk about any subject, you are only going to see the linear inductor. Okay, that is there is no problem here. But in some cases, for example, in EMFT, they can give you the non-linear inductor. But in network theory or in power system or in other subjects, you are going to see only the linear inductor. So in a linear inductor, the flux linkage is directly proportional to current. Okay. Now, if you talk about inductor, again, this is the important point here, plus minus V, the current I. So here, V is equal to L di by dt. It means the particular inductor is absorbing. If the inductor delivers the stored energy, it will be minus L di by dt. Again, important, plus minus की गलती नहीं होनी चाहिए. It is important. There should not be any mistake of plus minus here. Now, if you talk about inductor, it will act like a short circuit in case of DC. An inductor will act like a short circuit in case of DC. Now, if you talk about other points, if you talk about energy stored in inductor, it is equal to half Li square. And again, remember, instantaneous. Again, remember, it is instantaneous. In case of DC, RMS, instantaneous, everything is same. Okay. So that's why in case of DC, you can say it's a total energy. But for the general perspective, it is an instantaneous energy. Okay. Across the inductor, current cannot change instantaneously. Which means you can see, if the current change instantaneously, the voltage become infinite. That cannot be happen. So always remember, across inductor, the current does not change instantaneously. For a capacitor, voltage does not change instantaneously. Understood this point? Right? Now let's solve this question. Let's try to solve this question. In the interval 0 to pi by 50, a 30 millihenry inductor has a current I equal to 10 sin 50t. Obtain the voltage, power and energy of the inductor. Inductance लिखा हुआ, induct लिखा हुआ. 30 millihenry inductance. So obtain the voltage, power and energy for the inductor. Okay. Try to solve this. What we have given? We have given current I is equal to 10 sin 50t. Current I is equal to 10 sin 50t. Okay. Now, if you see, it is an AC circuit. It is an AC current that we have provided. Hai na? This is the AC current we have provided, and they have said we have to find out power and energy. Now, if they are saying only the power and energy, they have to specify here whether you need to find out average power, you need to find out average energy, or something else. They have to clarify here. If nothing is clarified here, what you have to do, you have to find out the instantaneous power and instantaneous energy. Okay. Otherwise, if you remember, the average power in inductor is 0. This point to remember now, that average power in inductor is 0. But this is for the average power we are talking about. If you talk about the instantaneous power, then it will not be equal to 0. Or if you talk about the power between some time interval, again it is not going to 0. Only the average power across the inductor is 0. Now there Ananthan saying, sir, voltage is minus 1500 volt. No, beta. V is equal to L di by dt we can use. So inductance is 30 millihenry. And it is 10 multiplied by 50, and the sign will give you the cos 50t. Cos 50t. Where you are getting minus sign? Tell me. So we have given 15 cos 50t. That we are getting 15 cos 50t. Hai na? Now, what is the power? The simple power formula, V multiplied by I. Always remember, this is a general formula. This is a general formula. Everywhere it can be used. Power, V multiplied by I. But remember, again, it is an instantaneous power formula. It is an instantaneous power formula. If you want to find out average power, what is the average power? 1 by T, integration of power with respect to time. This is the formula of average power. But in inductor, average power is always 0. So if they ask you the average power, just put equal to 0 there. So power is equal to V multiplied by I. V kitna hai? 15 cos 50t multiplied by 10 sin 50t. 150 by 2 sin 100t. Simple trigonometric identity. So this comes out to be power. This comes out to be power. Right? Now if you talk about energy, in energy that you can find out easily, half Li square. Just put all the values here. You will find out half Li square. But my question is, the next question, dhyan sunna, you have to understand this question. What is the frequency of power? In general I'm asking, not for the inductor. What is the frequency of a power? What is the frequency of a power? Krishna, average power of a capacitor. Batao answer. Bachche batao. What is the average power of a capacitor? What is the average power of capacitor? Now my question is, if current has frequency of omega and voltage had frequency of omega, then what is the frequency of power? What is the frequency of power? What is the frequency of power? Correct. Krishna, average power in case of capacitor is also 0. It's also 0. And Krishna is saying 2W. Absolutely correct. 2 times of W. 2 times W. Always remember, in case of power, the frequency doubles. Okay. But if I ask you this thing, let's suppose current has a frequency omega 1, voltage has a frequency of omega 2. Then tell me what will be the power frequency? If you have omega 1 and omega 2, what will the frequency of power? What will be the frequency of power? If you have omega 1 and omega 2, omega 1 plus omega 2 only. There should be not omega 1 minus omega 2. There should be not omega 1 minus omega 2 or the half of this. 2 times. No. Doesn't exist. No, power exists. Beta, power exists. In this case, you will have harmonics. For electronic student, you don't know about harmonics, so don't worry about that. But for the electrical students, there will be a harmonics here. Why there should not be a power? There's a harmonic content, but that is a power electronics part that we will learn there. Not worry about here. Next point. Next, try to solve this question. Acha question hai? Previous year hai? Don't worry about harmonics. I'm just asking in general. That is for the electrical, not for the EC. Now try to solve this question. I'm pretty much sure most of you have solved this question earlier. Figure shows the current flows through an inductor of resistance 1 ohm and 1 ohm and inductance 2 Henry. Determine the energy absorbed by the inductor up to first 4 seconds. Determine the energy stored by the inductor for the first 4 seconds. Okay, so we have given ABCD is the option. Try karo. ABCD is an option. No? So what we have given here, सब लोग try करो जब तक मैं थोड़ा solve करता हूँ यहाँ पे. So we have given a current and inductance, and total is the inductor here, है ना? But inside inductor we have 1 ohm and 2 Henry. So this is known as the lossy inductor. It is known as the lossy inductor. It means the inductor contain resistance also. Okay. So we have a lossy inductance here. They are asking what is the energy absorbed by the whole inductor. So energy absorbed by whole inductor is equal to energy absorbed by resistor plus energy absorbed by this particular inductance. Let's say small l. It is small l. Okay. So let's first find out energy stored by inductance. Now this you remember the formula half Li square. This formula only tells you the instantaneous energy. It will not tell you the energy between two time interval. So what formula we have to use? We have to just change this formula a little bit. In case of two time interval, this is the formula you have to use. The change in energy. Important point है ध्यान रखना. If you want to find out the energy stored in inductor, if you want to find out the energy stored in inductor between two time interval, this formula you have to use. Half Li square minus half Li square, and where current at different time instant. Now here, we need to find out energy till 4 seconds, from 0 to 4 seconds, from 0 to 4 seconds. So half Li square at 4 seconds minus half Li square at 0 second. At 0 second, the current is 0. At 0 second, the current is 0, so there is no energy. At 4 second, we have a current 6 ampere. So half inductance is 2. We have a current of 6 ampere, 6 whole square. It comes out to be 36 joule. So this is the amount of energy stored in inductor between two time interval 0 to 4 seconds. Okay. Now let's talk about the power. Energy stored in resistor. Energy stored in resistor. Now tell me which formula we can use here. To find out the energy stored in resistor, which formula we can use here? Which formula we can use here? Think about it. Which formula we can use here? V multiply by I, V multiply by I, or we can use this formula. I square R dt. I square R dt. We can use this particular formula. Not I square RT, because here you can see the current is not constant from 0 to 4. If the current is constant, then you can use the formula of I square RT. Or I can say, if you need to find out energy in this interval, then you can use the formula of I square RT. If the current is not constant, this is the formula of energy you have to follow, I square RT. But remember, this formula is only for the linear inductor, in which the Ohm's law is applicable. Okay, correct. Ananta is also said, also correct. So what is the I here? 0 to 4. What is the equation of I? What is the equation of I? You can see the equation of I here. It is equal to I is equal to 6 by 4 T. 6 by 4 T, or I can say 3 by 2 T. 3 by 2 T, है ना? So it will be 3 by 2 T whole square multiplied by resistance, which is 1 dt. So 9 by 4 T cube by 3 from 0 to 4. From 0 to 4. So it comes out to be 3 by 4. 4 whole cube. So 16 3 ja 48, if I am not wrong. Calculation check कर लेना. 16 3 ja 48, है ना? So what is the total energy? 36 plus 48. 84 joule. कहना कि I guess calculation की mistake हुई है. एक बार check करना. Or let me check here. 6 by 4. 6 by 4 we have done here. So 6 by 4 T square. So 9 by 4 we have taken. T square dt. The resistance is 1 ohm. Resistance is 1 ohm. So T cube by 3. So 3 by 4. We have given 4 cube. 16 is a 48. I guess calculation is correct, na? Calculation is correct. There is no problem in calculation. 84 are, but the 84 is not here. Let me check again. First 4 second पूछा है ना? ठीक है. तो I guess सही है. Calculation सही है ना? Sir, how you took 6 by 4? How you took 6 by 4? This is the equation of line. Y is equal to mx. The m is what? y2 minus y1. M is what? y2 minus y1 divided by x2 minus x1. है ना? तो y2 minus y1 divided by x2 minus x1. 4 minus 0. है ना? 6 by 4. सही है. I guess the options are wrong. हाँ. Otherwise it's correct. Okay, fine, no problem. Next question, try this one. Yeah, check. This is a nice question. A conceptual question. Conceptual question. Shivani said, "ठीक है, good." Conceptual question. Venkat, that was Venkat was asking. हाँ, so Venkat, that was a slope that I have taken 6/4. Correct. Wait a sec. Question remove. Try bro. It's good question. It's a conceptual question. In the interconnection of ideal sources shown in a figure, it is known that 60 volt absorbing the power. Which of the following can be the value of the current I? So one shot. Good na, naam bhi acha hai, one shot. 10 ampere. The name is similar to our series. Okay, so option A, 10 ampere. Okay, anybody else? Anybody else? Solve karo. Aram se solve karo. This is a conceptual question. This is a conceptual question. Think about it. Dekho, how you can solve this question. Before that, let's understand some tricks here. They have said which one of the following can be the value of current I. Whenever you see this word, can be, maybe, if you see this word, can be, maybe, it means you are not going to get the proper answer. You are not going to get a proper answer there. There should be some conditions or there's something that you are getting, but in the end, you are not going to get a proper answer there. That's why they have used the word can be, maybe. You know? Otherwise, they can use the word which of the following is the value of the current I. Then there should be a proper answer. Okay? So I would say absolutely correct. Now let's read the question. Ideal source shown in a source is absorbing the power. If 60 volt is absorbing the power, can I say the direction of current will be this? Because if the current enters the positive terminal, it means it stores the power. Now here you can see, and the other point they have said, in the interconnection, 60 volt source is absorbing power. Okay. Now apply the KCL here. Now apply the KCL here. I plus I is equal to 12. I is equal to 12 minus I. I is equal to 12 minus I. Now since it is absorbing the power, this we are sure that small I must be greater than 0. Why? Because it is absorbing the power, and here we have already shown that current is entering the positive terminal. It means the I must be greater than 0. So if I must be greater than 0, then 12 minus I must be greater than 0, or I can say I must be less than 12. I must be less than 12. So from this option, only option A is correct. Since I is less than 12, then only the 60 volt source will absorb power. If you take the current more than 12, then it will start delivering the power. Okay, understood? Acha question hai, conceptual hai, and this kind of words you should be very careful about when they use the can be and maybe word. Okay. Now before this question, wait a sec. First, we'll talk about the simplification of a network. So, what is the simplification of a network? That you have to reduce the network into a simple form so that the analysis becomes very much easier. So, in our course, we basically have three types of simplification. One is series parallel connection. Another one is star delta connection. And the third one is equipotential points. Equipotential points method. So basically we have these three methods. One more you can say the Wheatstone bridge. But it is a part of equipotential only. Wheatstone bridge, but it is a part of equipotential. So we have basically three methods. Series parallel, the two-port network will be covered in end. We have series parallel, star delta, equipotential, and the Wheatstone bridge method. Okay. Now let's talk about the series method. Series parallel connection. First of all, you need to identify the series parallel connection very carefully. That's the important point. So let me write down the formula quickly. I know everybody knows the formula, so I'm not going to waste the time here. So for a series, the total resistance will be R1 plus R2 plus so on plus Rn. If you talk about inductor, again everybody knows, but still if you have some doubt, you can ask. Otherwise, I'm writing the formula directly. We have Ln. Now if you talk about the capacitor here, in capacitor always remember it behave oppositely that of resistor. So 1 by CT is equal to 1 by C1 plus 1 by C2 plus so on 1 by CN. Okay, this is the series connection. If you talk about parallel, I'm writing down parallel directly. 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus so on 1 upon Rn. If you talk about inductance, inductance behaves exactly like resistance in case of formula. So plus 1 by Ln. And if you talk about capacitor, it will be C1 plus C2 plus so on Cn. है ना? Everybody knows this. Meghna, that you can that particular question will consume at least half an hour. So do one thing. You can go to the YouTube. You can search this and you can write my name there. You can get the complete video over this. In case of cubic, what is the equivalent resistance? Okay, there are 3 cases there that I have already explained. If I explain it in this class, it will consume half an hour time, and that question will never come in your exam again, because that question has already come in the previous gate examination. But still, if you want to understand, you can watch that video also. Okay, now let's solve one question over this. Let's solve one question over this. Question is find CAB. Find capacitance between the terminal AB. Find the capacitance between the terminal AB. Manaswani sir, solve PYQ more. Manaswani beta, PYQ, the questions we are solving, but we are more focused on the theory part. Because what is a revision actually? Revision is you go through one concept, and then you can apply the formula. That you can do it. But also we are solving all the questions that I am taking today's class is the PYQ question. But if you want a separate PYQ series, that has already happened on our YouTube channel. You can watch those classes also. Just one, yeah, you can also remember the final answers. There are 3 answers there, so you can also remember that. I don't remember the answer actually, but yeah, you can remember those 3 answers directly. One is 5R by 12, one is 7R by 12, something like this. I don't remember the formula, but yet you can remember it. Now try to find out the equivalent capacitance here between CAB. Special 26 series. Now it's in a special 26 series. Now I haven't take the previous year question. That was a question from different books and some different examination. I will send you a link. You can join my Telegram channel. I will send you a link of the previous year questions also. Also in today's class, also at today's 6 p.m. I'm going to take session on app. On a network theory, where I'm going to discuss previous year questions from the AC circuits. So all of you also join that particular class. You can only you can download the app and join the class at 6 p.m. today. There I will discuss approximately 15-16 questions which are previous year. So you can go through that particular class also today at 6 p.m. So try to solve this question. Try to solve. Anybody got the answer? Just share the link. You can download the app first and you can join my Telegram channel. There I will share the link before the class. PYQAC, PYQAC, correct. PYQAC. कैसे होगा? See very carefully. In the circuit in which you are not sure what is series and parallel. For example, here I'm not able to see what is series and what is parallel right now. What you have to do? You start giving names to the nodes. You have to start giving names to a node. So, for example, if this is a node B. If this is a node B, then from here to here, this is also node B. This is also node B. Why? Because there is no element connected in this branch. Now, here it is a node B. Let's suppose it is a node X. It is a node Y. Now, one thing you have noticed here, that between X and B, you have 2 capacitors. So between 2 nodes, you have 2 capacitors in which both of these capacitors are actually connected in parallel connection, So here I am redraw the circuit. I will redraw the circuit for you. Then you will get the answer whether you can solve this using star delta or not. See very carefully. So between A, B, and we have one node X. I have one node X and one node Y. Okay. Now between A, B, and Y, I can draw this. I have a capacitor like this. Between B and Y, between B and X, between B and X, I have two capacitors. Between B and X, I have two capacitors. This is an important point you need to understand. Between B and X, I have two capacitors. Between X and Y, I have two capacitors. X, I have one capacitor, and with Y, I have one capacitor. Okay. I have one capacitor like this, C, and one capacitor like this, C. So let me check. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now this is the simplified circuit. This is the simplified circuit. Can you solve this right now? This is not a star delta. Rajesh, you can see very carefully, and also Ananta. It's not the star delta, you can see, right? So here you can see these two capacitors. Since these two capacitors are given, wait a sec. So these two capacitors will become 2C. Now 2C and C. It becomes 2C by 3. I hope you know. I'm solving it directly. Now 2C by 3 and C are in parallel. So 2C by 3 and C are in parallel. It comes out to be 5C by 3. So the whole combination, this whole combination is 5C by 3. This whole combination is 5C by 3. Now 5C by 3 and C are in series. So I can say 5C by 3 and C are in series. So we can apply the series formula of capacitor here. So it comes out to be how much? 5 plus 3, 8. So 5 by 8C. 5 by 8C. Finally, this 5 by 8C and this C are in parallel. So 5 by 8C plus C comes out to be 13 by 8C. So who has given the right answer? Who has given the right answer? One student has given the right answer. I guess he removed the answer. 13 by 8C. Koi beta, if you are not sure about your answer, or if you think the answer is wrong, don't need to remove it. There is no negative marking here, right? But for example, my word has given a right answer earlier. So 13 by 8C is correct. 13 by 8C is correct. Now Wheatstone bridge. Wheatstone bridge again. Where you can see it's a Wheatstone bridge. What is the Wheatstone bridge, bacha? Think about it. Let me tell you. Wheatstone bridge. What is Wheatstone bridge? In a Wheatstone bridge, the terminal between which you need to find out the equivalent point is like this: terminal A, terminal B. So what is happening in a Wheatstone bridge? You have to skip one terminal, and then there is another terminal between. It means you need to find out resistance between the alternate terminals. But here you can see you are finding out a capacitance between the adjacent terminals. So there is no Wheatstone bridge. How you can say it? Wheatstone bridge. Wheatstone bridge के लिए ना आपको दो alternate particular terminals के बीच में equivalent निकालना होता है. But here you can see you need to find out the capacitance between the adjacent terminals. Okay, understood? Okay, fine. Next point here, star delta connection. Next point here is a star delta connection. So this is R1, this is R2, this is R3. I need to convert it into a delta. So tell me, everybody knows the formula? Yes or no? Tell me, everybody knows the formula? Yes or no? Payash, I hope you understand that was not a balanced bridge. Okay, that was not a Wheatstone bridge. Balanced to alag ho gaya. That was not a Wheatstone bridge. Now, I hope everybody knows the formula. I'm writing it down here. If you don't know, you can tell me. If you don't know, then you can tell me. Okay. R2, R3 plus R3, R1 divided by R3. You know? Same goes for RB. R1, R2 plus R2, R3 plus R3, R1 divided by R2. Everybody knows the formula, how to write this particular star delta formula? Yes or no? Finally, what is RC? R1, R2 plus R2, R3 plus R3, R1 divided by RC के सामने कौन सा है? R1 है ना? This is the simple conversion from star to delta. Now, what happened in case of capacitor? Always remember, if you have a capacitor, just you need to reverse it here. Means 1 by CA is equal to 1 by C1, C2, 1 by C2, C3. Just a reciprocal, bacha. Just a reciprocal. No need to remember the capacitor formula separately. You just have to do the reciprocal. That is the important point. Okay. Now let's solve one question over this. Let's solve one question over this. Let me think about it. This is terminal A, this is terminal B. Find resistance AB. Find RAB. All resistors are equal. All resistors are equal. Find RAB. All resistors are equal. Okay, this is R, this is R, R. Try to solve this question. All resistors are equal. This thing I have no idea. Try to understand this thing. My engineer is saying, acha. Whether you don't have any idea of star delta conversion, how to write down the formula? How to write down formula? Tell me. Try to solve this. Try to solve this question. Simple है. कैसे होगा? Let me solve for you. We have given three resistor RRR. All are in delta. All are in delta है ना? So first I have to convert delta to star. When you converting delta to star and all the resistors are same. When you converting delta to star and all the resistors are same, then resistor in star is equal to resistance in delta divided by 3. Remember this concept. है ना? Remember this concept. So here what we can do, I have a delta here, I have a delta here, I am converting it into a star. So now I have a star like this. I hope everybody understand this step. I have a star like this. I have a star like this. This is R, this is R, this is R, R by 3, R by 3, R by 3, R, R, R. Right? We have like this. Now again we have a 4R by 3 here. If you see here, every branch will be 4R by 3. So again I have a 4R by 3 here. So I can convert this star into delta again. I can convert the internal star into delta again. Yes or no? Each branch is of 4R by 3. Each branch is of 4R by 3. R plus R by 3. 4R by 3. So when you convert delta to star, when you convert star to delta, when you convert star to delta and all the resistors are same, then resistor in delta is equal to 3 times of resistance in star. So here you can see, if you convert this into a delta, you will get something like this. Parallel to each resistor, है ना? Understand this concept? This is R, this is R, this is R, and this is 4R by 3. So this becomes 4R. Every resistor here is 4R. Now it is easier to solve. I guess, है ना? कैसे? 4R and R are in parallel. When 4R and R are in parallel, you can write down 4R multiplied by R divided by 4R plus R. It will give you 4R by 5. It will give you the 4R by 5. Now this 4R by 5. Now you can see again, bacha. This 4R by 5, this 4R by 5, this 4 by 5 are in series. So I can say this is 8R by 5 and here I have again 4R by 5. Here again I have 4R by 5. Now both are in parallel. You can solve it. 8 by 15 are absolutely correct. Absolutely correct. Let me write down answer here finally. 8R by 15. When you solve that thing, you will get 8R by 15. Any doubt here? Next. Now try to solve this question. The equivalent resistance in the infinite ladder network. Question. Yeah, we will increase the speed a little bit. Good engineer. Hello Monali, how are you? So we'll increase the speed a little bit because we have seen the basics on now. And I'm going to skip a few topics. Like I will skip the KCL, KVL because I hope you know how to apply KCL, KVL. I will do the question directly over KCL, KVL, but not the theory part. Okay, bachcho? So KCL, KVL, mesh, super mesh, nodal, super node. We will solve question over it. I'm not going to tell you the theory over it. Okay. Telegrams are that's a part of network theorem now. So once we go through the KVL, KCL and mesh and super mesh, then we go to a network theorem. Okay, but telegrams is not that much important for your exam. Neither Miller's theorem. Now कैसे होगा question ये? Think about it. How you can solve this question? Now this is the infinite ladder question. Infinite ladder question means that you can see the one particular type of resistor is going to repeat till infinity. Is going to repeat till infinity. Now how you can solve this question? Very easily. कैसे? First of all, you have to note which type of resistor. You can note which branches are repeating till infinite. Here you can see this branch is repeating infinite. This branch is repeating till infinite. So what you have to do? You just need to keep one branch. And then assume the repetition of this branch is equal to X. It means the equivalent resistance of this particular network is equal to X only. It means the equivalent resistance of this side of network is equal to X. So if I redraw the network, the network will be like this. The network will be like this. This is X, this is R, this is R, this is 2R. So let me tell you again what we have done here. That we have assumed that the resistance of the repetition part is equal to X equivalent. Now here, understand one point. What is infinity plus 1 and infinity minus 1? In both the case, the answer is infinity. So here you can understand here, if the resistance of this complete infinite branch is X, so if I add the similar branch here, the resistance from this point is also X. It means here you can note here you can see bacho that from this point also the resistance is X. Why? Because in case of infinity, if you add one branch or subtract one branch, there is no effect on the equivalent resistance. So the equivalent resistance of an infinite is X. If I add one more branch, the equivalent resistance remains X. Okay, now let's solve it. So I can say what is X here? X is R plus X parallel to R. So we need to find out X here. R plus 2R plus X. कोई भी doubt हो पूछना. If you have any doubt, you can ask. बच्चों, you can ask. So from here we have X square minus we have X square. We have X multiplied by R minus R square equal to 0. So from here X comes out to be 4AC divided by 2. So we will not take the negative resistor. We only take the positive resistor. So this is going to be the value of X. But what they have asked, they didn't ask the value of X. They are asking the R equivalent. They are asking RE. RE starts from here. They are asking what is RE. Now here you can say what is RE. Here you can say RE is equal to 2R plus X. Why? This is the resistance 2R and the resistance of whole is equal to X. So it comes out to be 2R plus minus R plus root 5R divided by 2. So it comes out to be 3R plus root 5R divided by 2. This is the answer. Basically they have asked you the ratio. So the ratio here is 3 plus root 5 divided by 2. Simple question है. घबराना नहीं है, simple question है. Because this type of question has been asked multiple times in your GATE examination. You will check it. But this type of question you have understand in class 11th and 12th. 2.618. Okay. This we have already solved. 8 by 15 ohm was the answer. Okay. Now try to solve this question. Quickly. Sir, you can break starting 2R R plus R. That you can do, but that will not help you a lot, because you have to solve the same thing. That you can do, that's not worry. But if you break that particular resistor like this, this is R. Now the repeating branch is this one. But again, in the end you have to add this resistor. So there is no need to break the branches, because this particular resistor is not repeating. This R and R is repeating till infinity. Understood? So there is no use if you break it up, break the 2R into 2 resistor, because again the step will be same and again everything will be same. Okay, solve cross go. The three circuit elements shown in a figure, part of an electrical circuit. The total power absorbed by the three circuit elements in watt is. Power absorbed by the element. They are asking what is the total power absorbed here. What is the total power absorbed here? Let's talk about each element first. This is the element 1. This is element 2. This is element 3. If you see the element 1, the current entering the positive terminal. So in element 1, power is absorbing. So 10 multiplied by 100, it comes out to be 1000 watt. If you talk about by element 2, in element 2, understand very carefully, power is leaving the positive terminal. If power is leaving the positive terminal, it means power is delivering. But what you need to find out, a power absorbed. So power absorbed is equal to minus of power delivered. So minus of 8 multiplied by 80, it comes out to be minus 640 watt. Now, if you see very carefully, this is 10, this is 8, this is going to be 2 ampere. Here also you can note current leaving the positive terminal. So again, if you talk about the power absorbed, it will be minus of power delivered. So minus of 2 multiplied by 15, it comes out to be minus 30 watt. Now what is the total power? PA1 plus PA2 plus PA3. So it comes out to be 1000 minus 640 minus 30. So 673, 30 watt. So Shivani and there is one more on the Payash. My world Vardhan has given a right answer. Well done, well done. Yeah, easy concept, easy concept. Next. Now KCL, you know, I'm not going to explain the KCL. Everybody knows. Remember, this based on the conservation of charges. Okay. KVL, you know how to apply the KVL. Okay. So we will solve one question here. Let's solve this question. I hope everybody knows about this dependent sources. Okay, I haven't explained that because there's no explaining behind this dependent sources. You know, you have a 4 type of dependent source: current control voltage source, current control current source, voltage control voltage source, voltage control current source. You know, we have a 4 dependent sources. अच्छा, pious. अच्छा, मैंने वो pious समझा. अच्छा. Find V naught in the circuit in figure, the power absorbed by the dependent source. Okay, try to solve this question. Okay, now we are going to solve 5 to 6 question based on KCL, KVL, mesh, nodal, so that you will revise this concept easily. With every question, there will be some hidden point that I'm going to explain. Okay, that's why I'm going to solve these questions for you. So try to solve this question. And I hope you know everything about the dependent sources. So I'm not going to explain it again because that is going to waste our time only. And there's not that much explaining in the dependent source, right? Correct. Dependent sources are 4. Understand one thing about dependent source. First of all, source transformation is applicable on dependent source. Okay, you can write down for yourself. Source transformation is applicable for a dependent source. First point. Second, if in a circuit you have a dependent source, you cannot remove it. In a circuit, dependent source will always present. For example, while calculating the Thevenin resistance or while calculating anything, you cannot remove the dependent source. It will always present. No? Current division rule, voltage division rule, ये वाला बता दूँ मुझे? I will tell you. Now find V naught in a circuit. See very carefully. I know the voltage here is V naught. I know it is 10 ohm. Can I say that current flows here is V naught by 10? The current flows here is V naught by 10. Here it is 25 ampere. And here you can see 2 times of V naught. So I can say, if I apply the KCL here, V naught by 10 plus 2 times of V naught plus 25 is equal to 0. So कितना हो गया? Calculation check करते रहना. 21 by 10 times of V naught is equal to minus 25. V naught comes out to be minus 250 divided by 21. This is nothing but a V naught here. This is nothing but a V naught here. What you need to find out? The power absorbed by the dependent source. Here you can understand one point carefully, that First you need to find out voltage here. First you need to find out voltage here, because the current is given. Current is 2 times of V naught. I need to find out voltage, then only I can find out the power. So what is the, how you can find out a voltage here? How you can find out a voltage? Again, apply the KVL. If you apply the KVL here, if you apply the KVL here, 10 plus 10, 20, multiply by V naught by 10 plus VD equal to 0. So VD comes out to be minus 2 times of V naught. VD comes out to be minus 2 times of V naught, right? VD comes out to be minus 2 times of V naught. Now understand next point carefully. Understand next point carefully. They are asking power absorbed. They are asking power absorbed. But you have put the sign of voltage according to the power delivered, because the current is leaving the positive terminal. Current is leaving the positive terminal. It means power is delivering. So for finding out the power absorbed, I need to put minus of power delivered. Minus of power delivered, है ना? So power delivered is how much? Power delivered is 25 multiplied by 2V. VD multiplied by 2V naught. So minus VD multiplied by 2V naught. Now what is VD? It is 2V naught. Minus 2V naught. Okay. So it comes out to be 4V naught whole square. So 4 multiplied by, what is V naught? Minus 250 by 21. Of that you can solve it by using calculator. Yes or no? कोई भी डाउट हो, माइनस कैसे आ रहा है आप लोगों का? Tell me how all of you are getting minus. How all of you are getting minus. Wait a sec, let me use the calculator. Tell me how all of you are getting minus. If I have done some mistake here, you can also tell me. And meanwhile, let me solve this question. To whole square multiplied by 4. 566.89 आ रहा है ना? 566.89 आ रहा है. Let me check it once, because you are getting different answer. 13. Tell me 4 to 5 students are getting 13 answer. Where if I have done some mistake, let me check it. So first we have applied the KCL. V naught by 10, 25 to V naught. So it comes out to be 21 by 10. So minus 25. So from here V naught comes out to be this. Okay, fine, no problem. Then it comes out to be plus V naught plus 2 V naught plus VD. VD comes out to be minus 2 V naught. Remember, power absorption. Power absorption is negative of power delivered. Power absorption is negative of power delivered. है ना? तो negative of power delivered. तो VD multiplied by 2 V naught. This is voltage. This is current. This is voltage. This is current. This is voltage. This is current. So voltage is VD multiplied by 2 V naught. So VD is how much? VD is actually minus 2 V naught. So 2 to the 4 V naught square. Now, negative कैसा आएगा? Tell me, Shivani, how you will get negative? How you will get negative? See very carefully. This negative comes out because actually we assume power is delivering. Assume क्या है, हमने power deliver कर रहा है. See very carefully. According to this sign, you can note here that current is leaving the positive terminal. It means power is delivering. We need to find out power absorbed. So we have to put the minus sign there. First point तो ये हो गया. Next, what is the formula of power? Voltage multiplied by current, है ना? तो voltage here you can see VD. Current here you can see 2 V naught. V naught by 10 in opposite direction. अच्छा, Jaswant, why you will take V naught by 10 in opposite direction? In resistor, the current enters the positive terminal. Yes or no? In resistor, current enters the positive terminal. So the direction of current will be this, na? Why you will take opposite direction? Okay, Manasvi, just Manasvi. Sorry for wrong pronunciation. 567 volt. है ना? Jaswant, got it ना बेटा? कि you can see the plus terminal enters the current in case of resistor. ठीक है? And I guess everything is correct. Now before that, there is one more question I left. There is one more question, but before that, we have a current division rule. Let's understand the current division rule and voltage division rule. Then we will solve according to that. ठीक है? KCL. बेटा KCL लगा रहे हो. Then if you are changing the direction of current, then you will get a different. Then you will get everything with a different sign, opposite sign. In the end, you will get the same answer. In the end, you will get the same answer. Just you will get the answer with opposite sign everywhere. You will get V naught of opposite sign. Okay? Try it once again. Now, current division rule. Current division rule, let me tell you. So, we have R1, R2 and Rn. Ri, we need to find out the current passed through ith resistor. So what is the formula? What is the formula? Total current multiply 1 upon the resistor through which you need to find out current. अच्छा अभी मैं चेक करता हूँ, इसके बाद चेक करता हूँ, ठीक है. तो टोटल करंट इज इक्वल टू 1 upon Ri डिवाइड बाय 1 upon R1 plus 1 upon R2 plus so on 1 upon Rn. So this is the formula of a current division rule when you have a multiple branches in a branch. हाँ अभी चेक करो. You have this the formula of current division rule. What will happen in case of capacitor? If you have a capacitor, what happens? In case of capacitor, everything will be reciprocal. ITCI divided by C1 plus C2 plus so on Cn. In case of capacitor connected in parallel, every resistor will get reciprocal. Okay, understand this point. This is very important. Now, if you talk about the voltage division rule, in case of inductor, you have a same formula. बता रहा हूँ, ओजस सही बता रहा हूँ. Let's discuss this one. फिर मैं उसी क्वेश्चन में वापस जाता हूँ. Let's discuss this one. We will go back to that particular question again. Okay. So we have R1, R2, Ri, Rn. So what is the voltage across ith? Total voltage multiplied by resistance across which you need to find out R1 plus R2 plus so on Rn. Okay. But what happened in case of capacitor? In case of capacitor, it will be different. In case of capacitor, let me write down here. In case of capacitor, what will happen? If you find out capacitance between ith capacitor, so total voltage multiply 1 upon Ci across which you need to find out voltage. So 1 by C1, 1 by C2 plus 1 upon Cn. So remember, whatever the formula of resistor you have in case of current division rule, voltage division rule, in case of capacitor, you have to take the reciprocal there. Nothing else. Simple concept, right? Nothing else. Simple concept. So if in case of two capacitor, what happens? In case of two capacitor in series. So if you have a two capacitor in series, then voltage across the capacitor 1 is equal to total voltage multiplied by C2 divided by C1 plus C2. That actually come from above formula. Okay? So I hope you understand. You know this earlier. I just written here for your revision purpose. Okay? Otherwise, simple concept है, याद कर लेना, important है. Okay? And solve 2 or 3 questions over this. You can get this concept easily. Now let's talk about that question again. Okay. First of all, let's start from beginning. What I have done here, since the plus minus V0 is given, I have taken a current that enters the positive terminal. Now the current is V0 by 10. Here 25 ampere is coming. Okay. From here 2 V0 is coming. Now KCL is sum of current entering. So all 3 currents are entering, no problem, equal to sum of current leaving, which is 0, right? Now if I solve this, so plus 25 will go there, it will be minus 25, 21, so it comes out to be V0 equal to minus 250 by 21. Any doubt till this particular point? Because you can take the current in this direction also, no problem. You can take the current in this direction also, you will get plus 250 by 21. So any doubt till this particular point? ये कहाँ से आया? Right? Now let's talk about the voltage that we need to find out across it. The voltage is plus minus VD that we need to find out. Okay. So what I have done, I have applied the KVL. Now if I have applied the KVL, here you can see the same current is flowing here. So 10 plus 10, 20 multiplied by V0 by 10 plus VD. So from here, VD comes out to be minus 2 V0. Any doubt here? Simple. VD comes out to be minus 2 V0. अब बोलो क्या हो गया? Everybody. Payash, Anant. Any doubt till here? है ना? Now let's talk about what is happening here. If you see the polarity of voltage and if you see the direction of current, it is saying that power is actually delivering. है ना? Plus से current leave कर रहा है. Current is leaving the plus terminal. So power is delivering. But what we need to find out? Power absorption. So power absorption means negative of power delivered. है ना? Now negative of VD. What is the voltage across it? VD and 2 V0. Okay. तो VD multiply by 2V0. VD is how much? VD is minus 2V0. Minus 2V0. So minus plus. So it comes out to be 4V0 square. 4V0 square. Now V0 is already negative, but because of square it is positive. तो बताओ क्या दिक्कत है इसके अंदर? V0 by 10 is leaving from V0 है तो सर है, हमें डिपेंडेंट सोर्स से निकालना है. We have to find out for the dependent source. Dependent source से निकालना ना, तो in a dependent source 2V0 is leaving the VD. We have to find out for a dependent source. Are you finding out for something else? No. Now before going further, Abhinav sir is going to take a session on a wonderful session on how to get A's to 2025 in a first attempt. Also, we have a 90% scholarship program that is going to happen on 14th January. So if you are preparing for the GATE 25, you can avail this particular scholarship after giving the test. So all the best. Let's go further. Now, first of all, after the class, this is going to be the, what is the time right now? 11:40. So next 3 to 4 hours, we are going to take the class. After the class, you can scan this QR code and it will take you to the quiz. If you haven't downloaded the app, then you have to first download the app and then you have to go to the quiz. You can attempt the quiz and you can see how much you have learned from the marathon session. Okay, so don't forget to scan this QR. But a link I don't have. You can take a picture here now. If you're using your phone or if you're using anything else, you can just scan this QR code. ओजस बेटा नेगेटिव साइन कहाँ चला गया? बेटा नेगेटिव साइन उड़ गया. देखो कैसे उड़ेगा, देखो ओजस देखो ध्यान से. देखो पीडी कितना है? VD मल्टीप्लाई बाय 2V0, राइट. यहाँ माइनस है, राइट. अब VD कितना है? माइनस 2V0. तो मैंने यहाँ पर बस वो स्किप मिस कर दिया. माइनस 2V0 मल्टीप्लाई बाय 2V0 है ना. माइनस माइनस प्लस 2 2 जा 4V0 स्क्वायर. V0 इज दिस. सिंपल हो गया. नेक्स्ट, ये अच्छा. और प्लस माइनस में कहां गलती हो रही है जस्ट बेटा बताओ. नाउ ट्राई टू सॉल्व दिस क्वेश्चन. ओके, मतलब सेट ऑप्शन डी. ओके एवरीबॉडी ट्राई करो. 951 none of these. 951. अच्छा, गिव मी द रीजन फॉर ऑप्शन डी. बच्चा गिव मी द रीजन फॉर ऑप्शन डी. गिव मी द रीजन फॉर ऑप्शन डी. See very carefully. Now check. See very carefully here. You need to find out voltage V in this figure. So obviously you have to apply the KVL. There is nothing else you can do here. You have to apply the KVL. Now here you can see 2 ampere is entering the 2 ohm. So the voltage across it is actually 4 volt. The voltage across it is actually 4 volt. Now understand next point very carefully. बहुत ध्यान से. In this particular loop, बच्चों, you don't know the voltage across current source. You don't know the voltage across current source. If you don't know the voltage across current source, then how will you apply the KVL? When you are going to apply the KVL, you need the voltage across each element in the loop. I have this V, I have this 4 volt, I have this 5 volt, but I don't have a voltage across a current source. Since I don't have a voltage across current source, neither I can find out with the information given in this question. So that's why here KVL will not be applicable, or we can say we cannot apply. Not applicable, my fault. We cannot apply the KVL here. We cannot apply the KVL here because the voltage across the current source is unknown and we cannot find it. That's why the answer is option D. And this is the limitation. This is the limitation of a KVL. If you have a current source in a loop across which you don't know the voltage, you cannot apply the KVL. Okay, this is the limitation. इस limitation को याद रखना. Rajesh, how will you apply the KVL, beta? See very carefully. The voltage here is minus V. What is the voltage here? What is the voltage here? Next, the voltage across that is plus 4. Then we have a plus 5 equal to 0. But this is a incomplete KVL, na bacha? Because we don't have a voltage across the current source. Right? So this is the limitation of KVL. Remember this point. If you don't have a voltage across current source, you cannot apply the KVL. Invisible voice. First of all, bacha, we have already seen 3 sessions now till now, 3 revision subjects. One was two session, I guess, taken by the Rajesh sir. One is Sanjay sir, and another one by me. So first complete this 4 session. For a signal system, there is also a plan. I will show you the particular plan also. Let me show you. If you're asking it, let me show you. There's a schedule here. There's a schedule here. So in a signal, we have a 10th January. Acha, there's a timing at 10 a.m. I guess this timing has been changed. Okay, sorry. Signal system is already done yesterday. Signal system is already done yesterday by the Rakesh sir. So you can watch that class also. Manasuri Special 26 series has been completed now. For EC, that has been completed. Now try to solve this question. For the communication, which sir will take? I guess Saket sir. Saket Verma sir will take. Achha, yesterday control system will happen. Okay. Then in a place of control system, there will be a signal system. Okay. Now let's see. Kaise question here? What is the answer here? Option A, indeterminate, wrong. See very carefully. All these three branches are parallel. 4R, 4R, 2R. These are in parallel. If these are in parallel, can I find out the current across it? Kaise? Let's suppose this is I1. Let's suppose this is I2. Since all of these three branches are parallel, the voltage remains same. So I can say 4R multiplied by I1 is equal to 4R multiplied by 1 is equal to 2R multiplied by I2. Kyun? Because all other parallel branches voltage are same. So here you can see I1 comes out to be 1 and from here I2 comes out to be 2. So it is 1, it is 2. Then how much current is going here? Let's suppose it is I3. So apply the KCL. We have I1 plus 1 plus I2. I1 is 1 plus 1 plus 2. So it comes out to be 4 ampere. I3 comes out to be 4 ampere. Okay. If I3 is 4 ampere, let's find out resultant of these three resistor also. So 4R, 4R, 2R, 2R and 2R are. So here I can say the network is this. Here I can say the network is this. Enough? Here I know how much current is flowing. 4 ampere current is flowing. So we have 4 ampere. This is 3R. This is R. This is 2R. This is 4R. This is I. Now again you can see these three branches are parallel. 2R, 4R and the combination of 3R plus R. These three branches are parallel now. So can I say again 2R multiplied by I is equal to voltage of this branch which is 4R multiplied by 4. So I comes out to be 8. Option D. Option D answer. So correct. Ashok, my world has given the right answer. Option D. 8 ampere is the right answer. So you have to clearly see what is the series parallel combination. What is series parallel combination? Okay. Now mesh and super mesh. So first of all, everybody knows what is mesh. Mesh is the innermost loop in a circuit in which you don't find any other loop. Then you have a mesh there. Now what? For example, let's suppose this is the circuit. For example, let's suppose this is the circuit, 1 volt, 2 volt. Then here, how many mesh we have? We have 2 meshes here. We have 2 meshes here. Okay. Then it will be option D. Then if there is no across, then it will be option A. Okay? Now what is super mesh? Super mesh is a circuit in which there is a current source between 2 mesh. Super mesh is a circuit when there is a current source between 2 mesh like this. This is a super mesh circuit. This is the super mesh circuit. Why? Because here you can see we have a current source between 2 meshes. Now understand this point carefully. I told you the limitation of KVL, that KVL cannot apply in the loop in which we have a current source. The same limitation will be here. In this particular case, you cannot apply the mesh because here you cannot apply the KVL because the voltage across the current source we don't know. That's why we have to use the super mesh analysis. In super mesh analysis, what we have to do? We apply the KVL in this outer loop. Okay. So remember, super mesh circuit is a circuit in which there is a current source between 2 meshes. हाँ, current source of unknown voltage. Okay. What is nodal supernode? अच्छा, nodal is simple. In a nodal analysis, you apply the KCL. In a nodal analysis, you apply the KCL. So no need to worry about this. I think. Anshul, मैं समझी नहीं. Okay, let me tell you again, बच्चा. देखो, super mesh is a circuit if there is a current source between two mesh. For example, let's solve one question over this. Then you will understand. Let's solve one question over it. Four volt, 2 volt. This is 4 ampere, 3 ohm, 6 ohm. Fine. Fine. Voltage. Yeah, find mesh current. Simple. Find mesh current. Find mesh currents. You need to find out mesh currents here. Now see this question carefully. Manu saying, correct, absolutely correct, just one. Nodal analysis can be applied to super mesh also, absolutely correct. Machine and power electronics, better that we will plan. Right now we have plan of power system. Tomorrow I will take power system. So machine and power electronics will also plan. So here, first we have to find out, the mesh current. Okay, so let's assume the current here is I1. Let's assume the current here is I2. Now, first of all, you need to understand here, since the current source is present of unknown voltage, you cannot apply the KVL in this meshes. You cannot apply the KVL in this mesh. So what you have to do? You have to apply the KVL in outer loop. But understand here, the current enters here is plus minus I1 and here plus minus. So if you apply the KVL in outer loop, you will get minus 4 plus 3 times of I1 plus 6 times of I2 plus 2 equal to 0. This is the equation number 1. Any doubt in equation number 1? Why I have applied the KVL in an outer mesh or outer loop? Because inside we have a current source, we cannot apply the KVL. Next point, here you can see. According to our assumption, I1 is coming from above and I2 is coming from downwards. So here you can see the I2 is in same direction, 4 ampere. So can I say next equation, I2 minus I1 is equal to 4. This is the second equation. I2 minus I1 is equal to 4. This is the second equation. So again, you can solve this thing. You know, solving these two equations, you will get the answer. So this is actually a super mesh analysis. In super mesh, you have to apply the KVL outside the meshes, and also there is one equation based on the difference of the currents. Then you can solve it. Now, let me tell you the order that you have to check. What is the order? First of all, check whether you can apply the nodal or not. If you can able to apply the nodal, then apply the nodal analysis there. Because nodal is very much easier as compared to super mesh. Okay, next. If the nodal is not applicable, check for the super node. If nodal is not applicable, check for super node. If super node is not applicable, check for mesh analysis. And finally, go to a super mesh analysis. So this is the order that you should follow. 99% question will be solved using first 3 orders. There is only 1% question remain that you can go for a super mesh. Okay. Otherwise, 99% question will be solved using nodal, super node, and a particularly mesh analysis. Okay. Understand this point. Next, there is one more method. Current distribution method. In a current distribution method, what you have to do? You have to distribute the current in each and every branch using KCL and minimum variable, and after that you have to apply the KVL. So in a complex circuit, this particular method is very much reliable. Just you need to understand how to distribute the current in each branch. Okay, so let's solve one question. It's simple. Let's solve this question. Find the voltage and current in the circuit shown below. Okay, find the voltage and current here. Try karo. Find the voltage and current here. Try this question. And don't forget, try the quiz today also. Okay, try the quiz. You can scan the QR code and go to the quiz, and you can attempt that quiz, and you can see how much you have learned from the marathon session. I will show the QR code again when our class is going to be over. So try करो इसको. Thevenin's theorem. Now you are saying to apply Thevenin's theorem here. If you apply the Thevenin's theorem here, bacha, what will happen? You have a two load here, V and I. You are going to apply Thevenin's theorem across only one load. Otherwise, you need to apply Thevenin's theorem twice to find out V and I separately. So we don't apply the Thevenin's theorem here. Now see here what we can do. This is a super node circuit. This is the super node circuit. What is the super node circuit? The super node circuit is a circuit in which there is a voltage source only. Where, understand one point. Super node circuit is a circuit in which there is only a voltage source between two nodes. Only a voltage source between two nodes, right? That is known as a super node circuit. Now here, let's suppose the current flows here is I1. Here, the current flows here is I2. This is I. This I can take I3. Now, how to solve the super node question? Understand very carefully. You have to make one super node using these two nodes. This is actually a super node. This is actually a super node. Now here in a super node, you can check I1 and I2 are leaving. I1 and I2 are leaving. Here I3 and I are leaving. So it means if I apply the KCL at super node, I can write down I1 plus I2 plus I plus I3 are leaving equal to 0. Equal to 0. Now we can apply the, now we can find out the I1 here. So V1 minus 14. V1 minus 14 divided by 4. What is I2? V1 by 3. V1 by 3. What is I? V2 by 2. What is I3? V2 by 6 equal to 0. So the one equation will come from this. One equation will come from this. Now the second equation will come from where? Here you can check carefully. Here you can check. This is V1. This is V2. Between them you have a voltage source. So can I write down here V2 minus V1 equal to 6? Can I write down here V2 minus V1 is equal to 6? Yes or no? Carefully. ध्यान से देखो. V2 minus V1 equal to the 6 volt. So in this way, you solve the super node question. In a super node question, first you have to make one super node. And what is the super node? In which you have only voltage source between two unknown node voltages. From there, you have applied the KCL, and this is the equation again. V2 minus VQ, huh? Right, correct, है ना? Solve नहीं कर रहा हूँ, solve करने थोड़ा time जाएगा, but हाँ, equations are simple, you can solve it. Equations are simple, you can solve it. Okay, try to solve this question. Try to solve this question. How to follow polarity? Means which polarity you are saying, beta? Just one. Polarity means. Meanwhile, everybody solve this question. Are you talking about KVL? Are you talking about polarity in KVL or something else? Talking about polarity in KVL or something else? Achha, that polarity about our voltage source you are saying. Let me tell you one thing here. Be very careful. VA, VB, है ना? How you can follow the polarity? See very carefully how you can follow the polarity. But wherever you see the positive sign here, it means this is at higher potential, this is at lower potential. What is the voltage? Higher potential minus lower potential is equal to Vx. So this becomes this equation, है ना? Because the positive is connected to VA, negative is connected to VB. So you can learn like this, that the positive will be at higher potential and it will be at lower potential. So VA minus VB is equal to Vx. Understood this thing? And the same thing happened in the last question. In the last question, here you can see V2 is connected to plus, V1 is connected to minus. So V2 minus V1 is equal to 6, right? Now understand this question. First of all, this question, you cannot apply mesh. Mesh cannot be applied here. Okay, mesh nahi apply hoga. Second, nodal we can apply. Yes, nodal we can apply here. Super node to hai nahi hai. It is also a super mesh circuit, but we can apply the nodal. But if you apply the nodal, you can check how many equations will become. This is one node. This is the second node. This is third node. This is fourth node. So I have n equal to 4. So number of KCL equation will be 3. number of KCL equations will be 3. Now 3 equations will take much amount to solve this question. So this is actually a complex network because I have more than 2 KCL equations. So in case of complex question, try to distribute the current in each and every branch. For example, here you can see in this question 1 ampere, it is 1 ampere. 1 ampere and 2 ampere are entering. So 3 ampere will leave from here. Okay. Now I am assuming that current I is leaving from here. I am assuming current I is leaving from here. You know? So here it will be I plus 3. Here it will be I plus 3. The same current will go there. Now how much current will go here? I plus 3 is coming, 1 ampere leaving. So I plus 2. And finally at this node, 2 ampere or I ampere leaving. So what we have done here, it is a very important point. We have distributed the current in each and every branch. After distributing the current, you have to write down the KVL equation, and that will be equal to number of variable. कितने वेरिएबल है यहाँ पे? There is only one variable, capital I. Since there is only one variable, capital I, you need only one KVL equation. So earlier you require 3 KCL equation. Now you require only one KVL equation. That's why in case of a complex circuit, current distribution method is so much simple as compared to nodal or any other method. So apply कर दो, apply करो. If you apply the KVL here, minus 10 plus 2 multiplied by I plus 3, then there will be a 2 multiplied by I plus 2 equal to 0. From here, I comes out to be 0. From here, after solving, I comes out to be 0. है ना? So here you can see option A is the right answer because they are asking power delivered. So 10 multiplied by 0 gives you 0. Okay. So current distribution method is a very powerful method, but also a very trickiest method because many times you will get a wrong answer while applying this method if your concept is not good. That's why try to practice this method on about 5 to 10 questions, then you can get this method easily. Gautam, that's why I'm saying. It is an easier question. I'm skipping this question. Okay, so the easier question I'm skipping because we have already discussed about power. Na? We have discussed multiple times about power. So sign convention you need to remember. Okay, so we have completed the basic concepts. Now we are going into a theorem boundaries. So what I'm going to tell you in theorems, first of all, I am hoping this point that everybody knows the definition of theorem. कि सुपरपोजिशन थ्योरम क्या होती है, थेवेनिन्स, नॉर्टन्स, मैक्सिमम पावर थ्योरम, रेसिप्रोसिटी, टेलिगन्स थ्योरम. आई एम assuming this thing that you already know the definitions of this theorem, so I'm not going to explain that much. What I'm going to explain, the limitation of theorem, कि where you can use which theorem and what are the limitation of theorems that we are going to discuss. Okay, so first of all, let's talk about the superposition theorem. So what is the superposition theorem? One more point. Every theorem is applied only for the linear bilateral time invariant circuit. Only the Taylor's theorem is that which can be applied in any circuit, whether it is a non-linear, unilateral, time varying. Except that theorem, every other theorem will be applied only for the linear bilateral time varying circuit. Okay. Now what is a superposition theorem? It will tell you that total voltage is equal to, summation of individual voltage from individual source. What is VI? Output voltage due to output voltage due to ith source and all other sources deactivated. Ith source and all other sources deactivated. All other sources deactivated. है ना? Simple सा point है. You know this point. Similarly, if we talk about total current, that is also equal to I equal to 1 से and II. है ना? It means if you apply the superposition theorem, if you apply the what is bilateral, Gautam, you can watch my session from the starting. I have explained the bilateral there also. Okay. Harshanan, have you completed the network theory earlier? That's important. Na? Have you completed earlier? Because we are talking about the revision, so I cannot go into a depth of every question. Na? Now here, where was I? Superposition. So in a superposition, the total output is equal to summation of output from the individual sources, And remember, individual independent sources when all other sources are deactivated. Now in this case, always remember voltage source will be short circuit and current source will be open circuit. But remember, we never remove the dependent sources. We never remove dependent sources. Dependent sources will always present in a circuit. We only deactivate independent sources. That's the first point you need to understand. Second point, can I write the same for the power? Can I write the same for the power? Is this particular point is correct? Yes or no? Can I say that total power will be the summation of individual power from an individual source? Can I say this particular equation? Yes or no? Can I say this particular equation? Yes or no? And I can see कि 2 घंटे class हो गई and then students are starting to leaving the session. बेटा अभी तो start हुआ है. We have to revise many things. So those who are leaving the session, I will advise them कि just be in the class because we are going to revise transient also, AC also. Okay, Shinat said no. Rajesh said yes. The answer is no. In case of power, always remember, in case of power, superposition theorem is not applied. The superposition theorem is only applied for the voltage and current. For the voltage and current, always remember, it is only applied for the voltage and current. Superposition theorem is not applied for the power. What happens in case of power? If you want to find out the power, if individual power is given, it is equal to root P1 plus root P2 plus root P3 and so on raised to power whole square. So this will be happen in case of power where Pi is the power due to ith source, due to ith source only, due to ith source only, due to ith source only. Okay, this point is very much important. This point is very much important. Gautam, if it is not applicable for power, so definitely it will not applicable for energy. Simple. Superposition theorem is only applicable for the voltage and current. Is only applicable for the voltage and current. For example, let's solve one question over this. Let's solve one question over this. Let's suppose I have some passive network given. I have some passive network given and this is RL. And here we have plus minus V1 plus minus V2. Now it is given due to V1 the power we have is 100 watt. Due to V2 the power we have is 144 watt. And now the question is find power when both sources are active. Both sources are active simultaneously. Both sources are active simultaneously. When both sources are active simultaneously. Try karo this question. Sir, if two resistors draws power, if P1 and P2 and doesn't power known by them is not. Beta Ashik, I'm talking about a superposition theorem. What you are asking is a total power. That's different thing. Remember what I'm saying here. I'm saying about a superposition theorem. What is the superposition theorem here? It means power from the individual sources. It is not a power across a resistor. It's a power from a because of individual sources. For example, here I have written the power across RL due to V1 is 100 watt. Due to V2 is 144 watt. Then I'm asking if both the sources are active, then what will be the power? That I'm asking here. Okay, understand the question. The question is not कि आप resistor के across दो power है and you have to add this. That's a different thing. Okay, understand. 484 watt, correct. कैसे करोगे? Simple question. So here the power is equal to root P1 plus root P2 under root whole square. So it will be 10 plus 12 whole square. 484. 484 watt. Okay. Now there is one more question asked by Srinath. Plus or minus. Beta, if nothing is mentioned about maximum minimum power, you can directly use the plus. If they are asking you what is the minimum power, yeah, something else, then you can use the plus minus here. There's no problem here. You can use plus minus here. If they're asking the minimum power. Okay, otherwise they will ask you the simple power 484 watt. Minimum will be 4 watt. Minimum will be 4 watt. Correct. Understood? So remember, I'm talking about the power due to individual sources. This is an important point. Now, so this is the one point we need to discuss here. Now, one more point. We when the complete circuit is given, we usually don't apply the superposition theorem in exam because it will consume much amount of your time, because then you need to draw the circuit for each source and then you have to find out the final result. But in case of AC circuit, when you have a multiple frequency question, for example, let me do one thing here. For example, I have a AC network. And here I have connect a source of 50 hertz, and here I have connect a source of 60 hertz. So here you can see I have connected a source of different frequency. So in case of different frequency, you can only apply the superposition theorem. Nothing will be applied in a circuit if there is a multiple frequency source. If you have a multiple frequency source present in a circuit, then only and only superposition theorem is applied, nothing else. So in case of AC, superposition theorem is very important. In case of DC, it is not that important because it will consume much amount of your time. But if the question is like this, then only superposition theorem is applied. Better that we will plan about power electronics machine. Measurement is not that much important. Why you are worried about measurements? If you are from electrical background, the measurements you will get only two or three marks. 2 or 3 marks question you will get from measurement. That too is very much easier. So that you can do it by yourself, measurement. Right? Machine and power electronics we will plan. Tomorrow we have a power system class. Now Thevenin's theorem. So Thevenin's and Norton's theorem both are theorem. Let's discuss. What is the Thevenin's and Norton's theorem? If you have passive linear, my fault. If you have a linear bilateral circuit, across the load, then what you can do? You can convert this particular network into a constant voltage source across the load. Constant voltage source across the load. It is VTH, it is RTH, this is RL. This is the Thevenin's theorem. What about Norton's theorem? In Norton's theorem, you will convert it across the current source. So this is actually a Norton's theorem. RL, RN, IN. Simple hai, sabko pata hai na? Now here RN is equal to RTH. Here RN is equal to RTH and VTH is equal to IN multiplied by RTH. So these two equations are also important. Okay. Now one point I want to ask you. Can RTH be negative? क्या RTH negative हो सकता है? Can RTH be negative? The question is, can RTH be negative? Yes or no? Give the answer quickly. Can RTH be negative? The answer, yes or no? Talk about this. Now, next point need to understand about AC. Important points. First, no. Answer is no. I will solve it, Meghna. I will solve it. First, I will explain some important points. Then we'll solve question on RTH. First, RTH can be negative. RTH can be negative in case of dependent sources. If the network contain a dependent source, RTH can be negative because RTH is not a physical resistor. It is just the ratio of voltage and current. It is not a physical thing. So RTH can be negative. Next, RTH for a circuit is fixed. For a circuit does not depend on independent sources. Next point is very important. VTH and IN depends on independent sources. VTH is equal to A times of VS in case of reciprocal network. Let me write down everything, then I will discuss reciprocal network, or I can say a passive network. In case of passive network, and VTH is equal to A times of VS plus B in case of active network. A and B are constants. Let me explain. Let me write down this thing first. Okay, now let's explain it one by one. Let's explain it one by one. First of all, RTH does not depend on independent sources, because when you calculate the RTH, you have to remove the independent source. So obviously, if you're removing it, it's not depending on that. In case of VTH and IN, VTH is the open circuit voltage and IN is the short circuit current. In both the cases, we don't remove any source. That's why VTH and IN depend on the sources. So if the sources change, the VTH and IN will also change. Thanks, Manasvi. Then VTH and IN will also change. Next point. This point is important. For a passive network, output is directly proportional to input. For a passive network, according to the law of homogeneity, the output is directly proportional to the input for a passive network. But for an active network means the network contain dependent and independent sources. So for an active network, the output depends on input voltage plus constant. ये जो constant है B, this constant B is due to the unknown voltage source or current source present in a circuit. Okay, so this point is very much important to understand, because 2 or 3 times question has been asked over this. That in case of passive network, VTH is directly proportional to source voltage. In case of the active network, VTH is equal to AVS plus B. Okay, A and B both are constant. Now let's see how to find out RTH. So to find out RTH, there are two cases. There are two cases. Case one. There are two cases. Case one. No dependent source. No dependent source is present. If in a circuit, no dependent source is present. If in a circuit, no dependent source is present, what you can do? Remove all independent sources. Remove all independent sources and find R equivalent from load terminal. Case 2, dependent sources are present. Case 2, dependent sources are present. In this case, we have to use the test source method. Dependent sources are present. In this case, we have to use the test source method. Now, what is the test source method? In a test source method, what you have to do? Apply 1 volt or 1 ampere source at load terminal. 1 ampere 1 volt source at load terminal after removing independent source. So first we remove independent source. First we remove independent sources. Then we apply either 1 volt or 1 ampere at a source at a load terminal. If you are applying the 1 volt source, suppose here, if you are applying the 1 volt source, you will find out the current pass through it. So in that case, what is RTH? RTH is voltage divided by the current. Understood this point? If you apply the 1 volt source, then you have to find out the current pass through it. Then that current is I. So RTH will be 1 volt divided by I. If you are applying the 1 ampere source, you have to find out the voltage across that source. Then RTH will be that voltage divided by the current 1 ampere. So in this way, we need to find out RTH. And also there is a universal method. What is the universal method? Which is applied everywhere. That RTH is equal to VTH divided by IN. This is the universal method applied everywhere. Okay, understood? Now we are going to solve the questions one by one based on dependent source also or no independent source also. So let's talk about maximum power theorem first. Then we solve the question directly. Now what is the maximum power transfer theorem? According to this theorem, the maximum power will be transferred to a load maximum power will be transferred to a load when load resistor is equal to RTH. When load resistor is equal to RTH, and in this case, maximum power is equal to VTH square divided by 4 RTH. Yeah, these 2 points you need to remember. Now, one question has been asked by Ashik. Sir, when to use 1 volt and 1 ampere? See, you can use any source. There is not any compulsion that you have to use voltage source in this circuit or current source in this circuit. But I will give you one simple hint here that will help the question and solve the question in easier way. If across the load terminal, let's suppose this is a load terminal. If across the load terminal you have some parallel branch, then use the voltage source. But if across the terminal you have some series branch, then you can use the current source. Again, it is not the hard and fast rule. It is not any rule. It is just the simplification. कि अगर आपको एक branch मिल जाए across the load terminal, you can apply the voltage source, and if there is one branch in series with the load terminal, then you can apply the current source. Otherwise, you can apply any source, it will give you the same answer. Now the important points here, very, very important points here. First point, maximum power transfer theorem is only applicable if load is variable. This is very, very important. If the load resistor is variable, then only you can apply the maximum power theorem. Otherwise, you cannot apply the maximum power theorem. So it is a very, very important point. The load must be variable in that case. Okay? Understood this point? Next. Efficiency in case of maximum power transfer theorem is 50%. In case of maximum, if you find out the maximum power across a load, then the efficiency comes out to be less than equal to 50%. And that's why in many electrical and electronic device, we don't work on maximum power because we require the more efficient device. That's why we go towards the efficient device, because in case of maximum power, the efficiency is around 50%. And this is the disadvantage of the device which are using the maximum power. Sir, if the source variable, then no, that's not true. That depends on circuit. For example, let's talk about one question here. I hope you have solved this question multiple times because it's a previous year question, but this will help you to understand the concept that I'm telling you. So this is V, this is variable R, this is 6 ohm, this is RL equal to 3 ohm. Question is, find R for maximum power transfer. Find R for maximum power transfer. Find R for maximum power transfer. Spelling गलत है, spelling. Find R for maximum power transfer. Okay. Prakash says 0, Megan says 0. I know. You have solved this question multiple times. 0 or 3, 0 or 6, 0 or 6. What is the answer here? 0 or 6? 0 or 6. Now understand this question carefully. Here you can see the load resistor is fixed. The fixing of load resistance means that there is a numerical value given to a load. Understand this. Fixing of load resistance means that there is one value given to a load resistor. Variable load resistance means that the resistance value is not given. Okay, that is the main point you need to understand. So first of all, RL equal to 3 ohm is given. It means it is a fixed resistor. And since it is a fixed resistor, see the first point. Maximum power transfer theorem is applicable only if a load is variable. So what we have to write down here? Maximum power transfer theorem is not applicable. Maximum power transfer theorem is not applicable here, beta. Kyun? Because the load is fixed. Now, since you are using a maximum power transfer theorem, that's why you are getting 6 ohm as an answer. So Ashik and Vatla, you are getting a 6 ohm because you are using a maximum power theorem. But that is not applicable here because the load is fixed. So this is the first point you need to understand. So how you can solve this question? Now you can solve this question conceptually. This is the current. Power across load is equal to I square R. I square RL, it is equal to 9 times of I square. Now, to get a maximum power, understand this concept. To get a maximum power, I should be maximum. For the maximum current, total resistance should be minimum. है ना? Simple सी बात है ना? If you want maximum power, I should be maximum. Because of that, total resistance should be minimum. Simple. Now, if you want to get total resistance should be minimum, then R should be 0 now. When R is 0, the only resistance you have is 3 ohm. But when you take R of any other value, there will be a resistance more than 3 ohm, and hence current will not be maximum. Understand this point? So this is a very, very important point to understand. If the load is fixed, you cannot apply the maximum power theorem. Next, try to solve this question. I guess everybody is able to see the question, right? So now we are going to solve few questions based on theorems. Listen carefully. When the load is fixed, fixing of a load means some numerical value to a load is given. For example, in last question, 3 ohm is given to a load. It means that is fixed, that is not variable. In that case, you cannot apply maximum power theorem. Means RTH equal to RL. That we cannot apply it. Pehla point here ho gaya. Next, since we cannot apply it, we have to do it in another way. So what we can do? We have to apply, we can get a maximum current by taking R equal to 0. So if I'm taking R equal to 0, I'm getting a maximum current. Otherwise, if you take any other value here, for example, you are taking a 6 ohm, then it will comes out to be 6 ohm total resistance. Earlier it was 3 ohm, now it is 6 ohm. So the current is maximum only in case of 3 ohm, no? So that's why. So maximum power theorem is very critical theorem. You have to see in which you can apply it and in which you cannot. Now it is simple. First of all, this circuit I can replace via Thevenin's circuit. VTH, RTH, RL. VTH, RTH, RL. And this we have a load current IL, right? So first of all, I can write down IL is equal to VTH divided by RTH plus RL. Enough. So here I can say IL is 2 ampere, VTH I don't know, RTH is I don't know, and RL is 5. Second equation is 1 equal to VTH divided by RTH plus 15. So we have two equations. By solving two equations, I can find out VTH and RTH. Kaise? Divide both equation. So if I divide both equation, it comes out to be RTH plus 15 divided by RTH plus 5. So it gives you 2 RTH plus 10 equal to RTH plus 15. So RTH comes out to be 5. If RTH is 5, then VTH is how much? 20. VTH comes out to be 20 volt. Now they are asking what will be the load current when RL is 35 ohm. ठीक है. अच्छा यहीं पे solve करते हैं. So we can say what is the load current? It is equal to VTH divided by RTH is how much? 5 plus 35. So it will give you 0.5 ampere. So 0.5 ampere is the answer. Simple question hai. But this type of question has been asked many times in your GATE examination in both electrical and EC. This is known as a black box. Black box means the network in which we don't know about the configuration. So in general, we say it is a black box. Prakar, yes, we didn't apply reciprocity here because port is not changed. Correct. Now, before going further, let me tell you that Rakesh sir is going to take session on the aptitude, which is going to be a wonderful session for you because you need a 15 out of 15 marks in an aptitude to get good rank and marks in your GATE examination. Okay? So for that, Rakesh sir is going to bring an exclusive session only on the app. So download our app. In this app, first of all, after the class, after the marathon session, you can do the quiz there. First, second, there is a daily free classes going to happen there, so you can watch those classes also. Today at 6 p.m. I'm going to take class on the app in which I'm going to discuss the previous year question from AC circuits, so you can watch that session also, right? Please give how to apply the reciprocity. देखते हैं अभी. and the session is on 13 and 14 Jan. ठीक है. Now let's talk about the reciprocity theorem. But reciprocity theorem, first of all, it's for the examination. You will see only 1 or 2 times has been asked. So this theorem is very much simple. In this theorem, what is the meaning of this theorem? First of all, the network must be passive. The first condition, the network must be passive. Passive means there should be only resistor, inductor, and capacitor there. And now you have a two terminals. This is the input terminal. This is the output terminal. Now reciprocity theorem tells you that the ratio of excitation to response remains same if you interchange the terminals. What is the meaning of this thing? Let me tell you. Suppose I have a network here. This is plus minus V1 and across it I am taking I1. Okay? Now what I am going to do? I am going to interchange the terminals. Now if I am interchanging the terminal, let's suppose it is the current I2 at voltage of V2. So reciprocity theorem tells you that if you have a passive network and you interchange the terminals, then what you have to do? The ratio of excitation to response remains same. The ratio of excitation to response remains same. You need not to go to the network again and again if you're interchanging the port. So if you're interchanging the port, the ratio of excitation to response remains same. This is only the reciprocity theorem, but remember it is only applied in case of a passive network, not an active network. Okay. Now let's try to solve this question. Now we are going to solve this question carefully. Let's try to solve this question. Let's try to solve this question. This is a common data for a question. Read this data carefully, or you can note down this data carefully. Then I will show you the question. So once you note down this data, tell me, I will show you the question. Once you note down this data carefully, I will show you the question. With 10 volt connected at port A in a linear non-reciprocal network. Non-reciprocal network का मतलब क्या होता है? Active network. In a linear non-reciprocal network, 1 ohm connected to the port B gives the current 3 ampere. 2.5 ohm connected to port B draws a current of 2 ampere. You know? Now this is the question. For the same network, previous network, with 6 volt DC connected to port A, 1 ohm to port B draws 7/3 ampere. Okay? Extra information is given. One more, not extra, one more. If 8 volt DC is connected to port A, then what will be the open circuit at port B? Read the question carefully and try to solve this. Read the question carefully and try to solve this. Read this question carefully and try to solve it. You can see the data also again. How we can solve this question? See very carefully. I can convert this network into a Thevenin circuit. It is VTH. It is RTH. And here we have a load RL, which is actually variable. Okay? Now use this information first. They are saying 1 ohm connected at port B draws a current of 3 ampere. So this is IL. What is the formula of IL? IL is VTH divided by RTH plus R. So now they are saying 1 ohm connected 3 ampere. So this is 3 VTH divided by RTH plus 1. Next they are saying 2.5 ohm to 2 ampere ले रहा है. 2 is equal to VTH divided by RTH plus 2.5. So first of all, can you find out VTH and RTH here? है ना? Try करो, कितना होगा? 1.5 3/2 कितना हो गया? 3/2 is equal to RTH plus 2.5 divided by RTH plus 1. है ना? एक बार फाइंड करना कितना आ रहा है? तो 3 times of RTH आ जाएगा 3 5 2 आ रहा है क्या? Are we getting 2? हाँ 2 आ रहा है. So RTH comes out to be 2 ohm. RTH comes out to be 2 ohm. 4.53. हाँ RTH comes out to be 2 ohm. तो RTH 2 ohm, VTH कितना हो गया 3 volt. कहाँ चला गया जोश आप लोगों का है? Where is your Josh, guys? Eh? You are just watching the video and I am walking there from the last, I guess, 2.5 hours. So where is your Josh, bacha? है ना? Have you find out VTH RTH? Yes or no? Have you find out the VTH and RTH? This is 3 volt and 2 ohm. You can check the calculation also if I have done some mistake. So 3 plus 3. No, I have done some mistake na. 9 होगा. Sorry, 9 होगा. I know I have done mistake. There will be a 9 here. There will be 9 here. 4.59. So there will be 9 here. Okay. Now understand this thing very carefully. Understand this thing carefully. For source voltage equal to 10 volt. For source voltage equal to 10 volt, we are getting VTH equal to 9 volt and RTH equal to 2 ohm. Now one thing I told you earlier, then RTH will never change. RTH will never change. RTH will never change if you change the source voltage. VTH depends on source voltage. Okay. So now next, for the same network with 6 volt DC. Now they are saying 6 volt DC. It means the VTH will change. The VTH will change now. You cannot use this VTH here. So the VTH will change now. So if the 6 volt DC connected at port A, 1 ohm connected at port B draws 7/3 ampere. So now I don't know what is VTH, so I can say VTH dash, but I know the RTH remains same, which is 2 ohm. RTH remains same, which is 2 ohm, and now the load resistor RL is how much? It is 1 ohm. It is 1 ohm. So from here I can find out the VTH again. From here I can find out the VTH again. RL plus RTH. कैसे? कितना ये 7/3 एम्पियर है ना. हाँ ठीक है. 7/3 VTH dash I don't know. Load is 1 and RTH is 2. So it comes out to be VTH dash is equal to 7 volt. So this VTH is for what? This VTH is for the 6 volt. Understood? This VTH is for the 6 volt. This is for source voltage equal to 6 volt. है ना? Now they are again change the source voltage. Now they are saying if 8 volt is applied to DC, what is the open circuit voltage? Open circuit, they are asking the VTH. Nothing, they are asking a VTH. It means they are asking what will be the VTH if 8 volt is applied. We know the VTH for 10 volt, it is 9 volt. We know the VTH for 6 volt, it is 7 volt. We need to find out the VTH for the 8 volt. Okay. So कैसे निकालेंगे? So we have non-reciprocal network. We have non-reciprocal network. Non-reciprocal network means active network. In case of active network, I told you VTH is equal to A times of Vs plus V. Just I told you earlier. Now for the VTH is how much? VTH is 9 for 10 volt. Okay. 9 is equal to 10 times of A plus B. Also VTH is how much? 7 volt. 7 is equal to 6 times of A plus B. तो इसको solve कर लो कितना आएगा? So A comes out to be 1/2. B comes out to be 4. A comes out to be 1/2. B comes out to be 4. So VTH is equal to Vs by 2. Vs by 2 plus 4. Now if Vs is 8 volt. If Vs is 8 volt. Then VTH is 8/2 plus 4 comes out to be 8 volt. Option C is the right answer. Option C is the right answer. How you are getting option D? How you are getting option D or 7 volt beta? Option C is the right answer. Na? I told you earlier that this formula is important. If you have a non-reciprocal network or active network, this formula is important. So we have find out 10 है. एक बार मैं calculation check कर लूँ. So A comes out to be 1/2. ये तो सही है ना? So Vs हाँ. It comes out to be 8 volt. It comes out to be 8 volt. Correct. Correct Shivani. Correct Payash. है ना? Charya, what you are asking? Trinitra Charya. Sorry for the wrong pronunciation. Error. Now next. Try to solve this question. Same, for the same question. With 10 volt DC connected at port A, the current drawn by 7 ohm connected at port B. Simple है. Current drawn कितना था? VTH divided by RTH plus RL. Now we already know VTH for the 10 volt. Already know VTH for 10 volt is 9 volt. So 9 RTH कितना है? RTH 2 plus 7, it comes out to be 1 ampere. 1 ampere आ रहा है. Maybe sure options are wrong. हाँ, options wrong है. Options wrong है. It's a previous year question here, I remember. So it comes out to be 1 ampere. It comes out to be 1 ampere. है ना? VTH 9 था ना यहाँ पे? VTH is 9 here. Okay. And we have RTH is 2, RL is 7. हाँ, 1 ampere. It is right. I remember the answer of this. It is right. Okay. अच्छा. Shivani Singh, break sir, please. What would you do in a break, बच्चों? Tell me, what will you do in break? Either you will eat something, है ना? You will do something. So you're watching the class. You can eat it while watching the class, right? है ना? So you have to go somewhere for the lunch. Okay, I will give you break at 1 p.m. 1 p.m. At 1 p.m. I will give you break for 20 minutes. I will provide you the break. Then we will continue 2 hours of class. Then after break, ठीक है? But Arenis, no sir. I guess you have already done lunch, है? Okay, but take a break, because continue some time in continue class na. There will be fatigue also for the students. Tell me the timing. 1 p.m. 1:30 p.m. Tell me the timing. 1 p.m. or 1:30 p.m. Meanwhile, also try to solve this question. Okay, Ashok said 1 p.m. Okay, so vote for the 1:30 में भी एक और आ गया. 2, 3, 4. Okay, so vote for the 1 p.m. is more. So we will take 20 minutes break at 1 p.m. Okay, but you have to promise me that you have to come back. Okay, you have to come back after a break, because I have seen in Rakesh sir and Sanjay sir class also that after break the attendance has been reduced. So I am expecting that you will come back after a break, because we are going to discuss transients and the two-port network after a break. That's going to be very, very important for you. Okay. Now let's solve this question. Let's solve few questions and I will give you the break. Okay. Now let's solve this question. We have given VI characteristic here and we have to find out the current I1. Now understand the VI characteristic. Which password, just one, which password you are asking? So let's talk about this. So whenever you have a VI characteristic of a network, this is a terminal voltage, terminal current. Always remember the intercept are actually the Thevenin's voltage and Norton's current. Intercept are actually the Thevenin's voltage and the Norton's current. This is important. Okay? So whenever you have a VI characteristic, this will tell you the intercept. So we have given VTH equal to 6 volt and Norton's current equal to 6 milliampere. I'm not taking a minus sign here. I'm not taking a minus sign here. Which PDF you are asking, guys? Tell me which PDF you are asking. I'm not aware of that. So since there is, I'm not taking a minus sign here. Why? Because no polarity has been shown here. If the polarity across the network is shown, then you can take a minus sign. Otherwise, there is no need to take the minus sign. The session PDF. Okay, I will tell you. I don't know about that, but I will ask the technical team and tell you. Okay, what is the password for a session PDF? Okay. Now VTH 6 volt, IN 6 milliampere. From here, I can find out RTH, which is equal to VTH divided by IN. So 6 divided by 6 into 10 to the power minus 3 equal to 1 kilo ohm. So RTH comes out to be 1 kilo ohm. Now this 1 kilo ohm RTH and VTH are same for both the circuit. So we can say plus minus RTH here also. I can write down here plus minus. So VTH is how much? 6 volt. So it is 6 volt. It is 6 volt. And we have 1 kilo ohm. It is 1 kilo ohm. It is 1 kilo ohm. And we have given a resistance of 1 kilo ohm. Now you need to find out I1. Now the question is simple. But remember one thing very carefully. The intercepts here. So कैसे solve करोगे? I2, I3. So if you apply the KCL, I am applying the KCL directly. V minus 6 divided by 1 plus V by 1 plus V minus 6 divided by 1 equal to 0. कितना हो गया 3V, V comes out to be 4 volt, V comes out to be 4 volt. So what is the small I? 4 divided by 1 comes out to be 4 milliampere. Absolutely correct. One student has given 6 milliampere, but Anandan saying absolutely correct, 4 milliampere. Okay, now try to solve this question. Correct. My word has given 4 milliampere. Bhanu is correct. Ashok is correct. Shivani is correct. Well done. In the network shown below, the measurements obtained are given in the table. If V1 is 10 volt and V2, if V2 is 5 volt, then the current is. If V2 is 5 volt, then the current is. First of all, tell me which theorem we can apply here. First of all, tell me which theorem we can apply here. Which theorem we can apply here? REC कौन सी होगी? Reciprocity. बेटा, where I have changed the load terminal. When you change the load terminal, when you interchange the port, then you apply the reciprocity. Na? The port is fixed here. How will you apply the reciprocity? This is the output. Na? So this port is fixed. Na? Why you will apply the reciprocity? Na? No reciprocity. Here we have to apply the superposition theorem. Why the superposition theorem? Because the multiple sources are given. Remember, the Thevenin's and Norton's theorem is applied in a black box only when a single source is given. For example, in the last question, a single source is given. That's why we have applied there the Thevenin's and Norton's theorem. Here we have given two sources here. So we cannot apply Thevenin's and Norton's. We have to apply the superposition. So here I can say I is equal to A times of V1 plus B times of V2. Now understand this point. They have given a passive network. Since the passive network is given, there will be no source inside it. So we can directly say the output will only depend on V1 and V2. Output will not depend on anything else. It only depends on V1 or V2. Okay, now put the relation here. So I is 1 when V1 is 4 and V2 is 0. So from here A comes out to be 1 by 4. Again, I is minus 1 when it is 0 and it is 5 times of B. So from here, B comes out to be minus 1 by 5. So simply I can say, what is the current I? It is equal to V1 by 4 minus V2 by 5. Now they are saying, agar V1 10 volt ho jaye, V2 5 ho jaye, what will be the current? है ना? Simple, you can find out. So 10 divided by 4 minus 5 divided by 1. So it comes out to be 6 by 4, 1.5 ampere. 1.5 ampere. Okay, so understand this point. This we can only write down in this form because the passive network is given. If there is an active network, then there will be one more variable. For example, if the active network is given, then there will be one more variable like this, plus C. Okay, plus C. Okay. Sorry. Now try to solve this question. Thevenin's equivalent resistance, because we haven't seen the RTH wala concept na, dependent source wala. तो वो आपको दिखा रहा हूँ how to apply how to find out RTH in case of dependent sources. Let's discuss that question and then we will take break. RTH in case of dependent sources, है ना? Here you can see we have a dependent source. 3I0 have a dependent source. So what you have to do, बच्चों? What you have to do? First you have to remove all the independent sources. First, you have to remove all the independent sources. So what are the independent sources here? What are the independent source? 10 volt. So it will be short circuit. So how you can draw the network? You can draw the network like this. You can draw the network like this, and we will remove the independent source like this. And this is 3I0. This is 3I0, and here we have P. We have Q, है ना? This is 1 ohm. This is I0, 1 ohm, 1 ohm and 1 ohm. Right? We got this. Now, since we have a dependent source present, you have to apply the test source. You have to apply the test source. Now, how you will apply the test source? See very carefully. Yes, in an active circuit, superposition theorem is applicable. Now, which test source I will apply here? I will apply the voltage source. I will apply the voltage source. So the voltage source applied here is 1 volt. I need to find out the current passed through it, I. So how much current it is delivering, that I need to find out. I need to find out the current I here. Okay. So कैसे करेंगे? Now after applying the voltage source, you can there will be no current passed through 1 ohm because it is short circuit. Now after applying the voltage source, you can see what is I naught. I naught is 1 divided by 1 equal to 1 ampere. है ना? Because the voltage is here. So we know the I naught. Now how you can solve this question? Also, can you find out the current here? Can you find out the current? Let's suppose it is small I. So what is small I here? What is small I here? You can see the small I is equal to 3 I naught because ये voltage source है. Divide by 1. So it comes out to be 3 ampere. So we have a small I also. Let's suppose what we can do now. Okay, we have a small I. We have this. Okay, fine. Now distribute the current. Here you can see I naught is coming, I naught is leaving, and I is coming. So I can say how much current is going here. I will say I plus I minus I naught. This much current is going through 3 I naught. Now from here I will leave. So how much current will enter here? I minus I naught. It will be I minus I naught. So we have distributed the current in each and every branch. Now apply the KVL, because only one variable here, which is capital I. We already know the value of I naught and I. So let's apply the KVL. So we can apply the KVL where? We can apply the KVL anywhere you can apply. Here you can apply. Just take this particular loop and apply the KVL. So if you apply the KVL, it will be -1 minus 3 times of I naught. Going further, I have 1 multiplied by capital I minus I naught equal to 0. है ना? So -1 minus I naught is how much? 1 ampere. So 3 हो गया plus I minus 1 equal to 0. So I कितना आ गया? 4. I equal to 5. I equal to 5 ampere आ गया. I equal to 5 ampere आ गया, है ना? If I equal to 5 ampere, what will be the RTH? 1 divided by I, 1 divided by 5 equal to 0.2 ohm. So this is the RTH. Okay. Why I have written 1 here? Because the voltage source is 1. Understood? In this way you apply the test source method. Ashik is saying, for the same question, if it's active network, will there be any change in answer? Yes, there will be a change in answer, Ashik, because I told you in case of active network there will be one more variable plus C. There will be one more constant plus C will come in this question. If there is an active network, and they have to given one more condition then, because then you have a 3 variables A, B and C so you require 3 equations. Understood here? Yes or no? Any doubt in this particular concept? We have seen the theorems, we have seen the basics right now. Now after the break, we are going to see the transient question. ठीक है? Transient question हम देखेंगे. In transient question, I will tell you the shortcut tricks and everything else. ठीक है? So there is a break. I'm going to break here. So we will take a break. $20 break है. So 1:15 then. We will return at 1:15. Okay. We will return at 1:15. Why did you attempt gate 7 times even after qualifying? But I have attempted the gate 7 times just for the sake of, because as a faculty, if you are not aware of the exams that you are teaching, then you will not going to up to date to that. So to get up to date for the examination, you have to give examination. You have to give that particular exam. Now in most of the exam there is an age limit, so the faculties cannot give that particular exam. But in GATE there is no age limit. So that's why if you are giving a GATE exam, तो I am aware कि हाँ इस टाइम पर बच्चों को किस तरीके से उनके ऊपर प्रेशर होगा या कैसा उन्होंने अटेम्प्ट किया होगा. Because इफ द क्वेश्चन विल कम टू मी आफ्टर द गेट एग्जाम, तो मुझे पता है कि वो सॉल्व हो जाएगा। बट एक एग्जाम एनवायरनमेंट में आप लोग कैसे फील करते हो, आप लोग कैसे उसको टैकल करोगे, वो तभी पता चलता है व्हेन यू आर गिविंग दैट एग्जाम, है ना। अदरवाइज ऐसे तो हम लोग, आप क्वेश्चन दोगे हम लोग सॉल्व कर लेंगे। -1 कहाँ आ रहा है बच्चे, -1 कहाँ आ रहा है? -1 नहीं आ रहा है? यस बेटा, -1 नहीं आ रहा। ठीक है, सो ब्रेक ले लेते हैं, वी विल मीट एट 1:15 PM। ठीक है, बट बी ऑन टाइम, ये मत करना कि आओ नहीं सो जाओ खाना खा के। ठीक है, सो बी ऑन टाइम एट 1:15 PM, राइट। लाइफ में नहीं आ रहा, इसका काउंटर फिक्स हो गया। हेलो एवरीवन, बताओ कौन कौन आ गया सेशन में। टेल मी हु हैज जॉइन द सेशन अगेन। So we are going to continue. We are going to continue our session. So till now, till the break, we have completed the chapter 1, chapter 2, and we have done the basics also, right? Now what we have to do, we are going to start the transients. Okay, transients is one of the important chapter from your network theory, and definitely you are going to get at least 3 marks question from a transient. Okay, so transient काफी important है. We are going to discuss transient, and we will discuss the transient in a less amount of time and in more efficient way. Okay, because most of the things you know, ki what is transient, what is the shortcut formula. I will show you one particular flow chart, and with that particular flow chart, you can solve any question of transient. Okay, so tell me in a comment section who has joined the session again quickly. बताओ कौन कौन वापस आ गया। Okay, we are going to start just in 1 or 2 minutes, but before that tell me who has joined. Well, I can see few people are live online, and also share the session among your friends so that more and more students can join it. Okay, good afternoon Arya. Transient response. Okay, so we'll start now. So bachcho, if you see the transient analysis, good afternoon Shinag. If you see the transient analysis, what is actually a transient? Simple सा concept होता है. The simple concept is that whenever there is a disturbance occur in a circuit, then a sudden burst of energy flows, and that is known as a transient condition inside a circuit. The disturbance can be your switching, the disturbance can be the short circuit, the disturbance can be any type of fault like lightning, anything else, but the disturbance must be a sudden. So if there is a sudden disturbance occur in a circuit, then there is a burst of energy that flows in a circuit, and that is known as a transient. And after that burst of energy settle down, then we got the steady state. So in a steady state, what happened? We got the constant state. Now constant state doesn't mean that voltage and current remain constant. No, the steady state means in which you got the equilibrium of energy. Okay. So good afternoon, Guru. Good afternoon, Manasvi. Okay, so let's discuss it. So what is the transient response? So the transient response in the circuit is a temporary response that will die out with time. This is important. Transient response will die out with a time if you have a stable circuit. If you don't have a stable circuit, then there will be a transient response throughout it, and that's why the unstable circuit is not physically possible. Yes, Shivani, break over. Now next point. The transient where the signals are highly dependent on time, there is no voltage or current source. This response is known as natural response, and transient solution is a solution of the homogeneous equation. So only complementary function exists. Okay, everything is written here, and I know that you have already know all of this thing. So I'm just going to jump to the main part of a transient analysis. Good afternoon, Prash. Now, main part of a transient analysis. First of all, what is the meaning of first order? What is the meaning of order of a circuit? Order of circuit is equal to number of energy storage element present in a circuit. Number of energy storage element present in a circuit. Okay? Now first order means there will be either only capacitor or inductor present in a circuit. There will be either a inductor or capacitor present in a circuit. For example, we have RL or RC circuit. Whereas second order circuit means there will be a combination of LC. So there can be a 2 inductor, there can be a 2 capacitor, there can be 1 inductor and 1 capacitor also, known as the LC circuit. So this is important, first order and second order. For the examination, we have only the first order and second order circuit. Higher order circuits are not in your exam, although if the higher order circuit question will come, that is also will be solved like the second order circuit only. Now there is an important point here about the time constant. Do you know what do you mean by time constant? Does anybody knows the meaning of time constant? Anybody knows the meaning of time constant? Now, first of all, always remember, for transient response, if a network has a transient response, then they must have two conditions satisfied. The first condition, the sudden change. The first condition is a sudden change, and the second condition is energy storage element. So both of these conditions must be satisfied. Energy storage element. Both of these conditions must be satisfied, then only a circuit will have a transient response. If any of these condition is not satisfied, then there will be no transient response in a circuit. Okay, understand this? This point is very much important. Now, if you talk about the energy storage element, then we have inductor and a capacitor. We have an inductor and capacitor. Inductor store which type of energy? It store the magnetic energy, whereas if you talk about capacitor, it store the electrical energy. Okay. Now, when we talk about time constant, it represents by symbol tau. What is the time constant? It is the time at which element discharge to 37% of initial value, discharge to 31 initial energy, or 63, or you can say element charge to 63% of final energy. इसका मतलब क्या हुआ? Understand this concept carefully. You have energy storage element. It can either charge or discharge. And that's why the time constant definition will change according to that. In case of discharging, time constant is the time at which the particular element discharged to 37% of initial value. In case of charging, it is the time at which the element charged to 63% of the final value. So according to the charging, discharging, the definition will change. Now, time constant, if you talk about the first order circuit, in case of a first order circuit, time constant is simple. Time constant is equal to L divided by R equivalent. And in case of RC, it is 1 divided by R equivalent multiplied by C. Now understand one point here. What is R equivalent? R equivalent is nothing but it is the resistance of dead network. Dead network means after removing all the independent sources, whatever the network remains, you have to find out the resistance of that network. Just like the Thevenin resistance. The procedure to find out the R equivalent is just like a Thevenin resistance. Okay, understand this point. One more point. Along the inductor or capacitor. This is also important. When you are going to find out R equivalent, the one point is important here. It should be find out along inductor or capacitor, not across any other terminal. This point is important. Okay. So for a first order circuit, the time constant is equal to L by R equivalent, also 1 upon R equivalent multiplied by C. Now, if you talk about the second order circuit, in a second order circuit, never use this formula. For a second order circuit, never use this formula because this formula is only applicable for first order. In exam, they will never going to ask you what is the time constant for the higher order network, है ना? But still for some questions, difference equation for RLC nahi. For still, I'm giving you just basic information. I'm giving you one basic information that whenever they are going to ask you the time constant of higher order circuit, what you have to do? You have to find out the characteristic equation of a network. Do you know what is the characteristic equation of a network? The particular Laplace transform. You need to find out a characteristic equation of a network, and then what is the time constant? Time constant is equal to 1 divided by the dominant pole. So this is the general formula to find out the time constant. For example, we have zero pole diagram. Like this. This is pole 1, this is pole 2. Now, what do you mean by dominant pole? Tell me. What do you mean by dominant pole? Tell me, guys. What do you mean by dominant pole? Think about it. Think about it. What do you mean by dominant pole? Anyone? Anyone? खाना खा के सब सो गए क्या? खाना खा के सब सो गए. Dominant pole means the pole which is nearest to the origin. The pole which is nearest to the origin, that is the meaning of dominant pole. Correct. So if you want to find out the time constant, that will be equal to 1 divided by T1. Okay. Wait a sec. Okay. Understand this point? Correct. Correct. Absolutely correct. Absolutely correct. Okay, so this is important. Although they will not ask you the time constant of higher order circuit, first order circuit is important here. Now let's talk about the timing diagram. From here, we are going to start the transient properly, and we are going to explain. We are going to understand a transient in a less amount of time. Okay, so let's talk about the timing diagram. So in a transient analysis, there are few times that are very important. They are very important. What are the few times here? Let's see. This is t equal to 0. T equal to 0 is what? T equal to 0, time instant of switching. मतलब time instant at which switching occurred. Time instant at which switching occurred. T equal to 0 is the instant at which the particular switching occurred. It can be open switch, it can be closed switch. So T equal to 0 is the instant at which the switching occurred. Now the next interval is very important. Next instant is very important, t equal to 0 plus. And also one more instant, t equal to 0 minus. So what is 0 plus and 0 minus? T equal to 0 plus momentary time, मतलब very small. Momentary time just after switching. Momentary time just after switching. And t equal to 0 minus is what? Momentary time just before switching. Momentary time just before switching. Understand this concept? So t equal to 0 plus, t equal to 0 minus, both are very important time instant. Next time instant we have is the settling time. This is TS. It is the settling time. What is the settling time? The time at which the transient dies. The time at which the transient dies. It means the transient has been started from here. It means this is the interval of transient time. This is the transient time. This is the transient time. Now understand this concept. When the transient dies, what you have? You have a steady state. When the transient dies, then you will have a steady state. Now understand one point here also. Before the transient occur, there also be a steady state. Before the transient occur, there also be a steady state, because earlier the circuit is in equilibrium, the circuit is not disturbed. You have suddenly disturbed the circuit. Once you suddenly disturb the circuit, the transient state will start, and once the transient state will end, you have a steady state. This will tell you one point carefully. That t equal to 0 minus is part of a steady state. T equal to 0 minus is a part of a steady state. Also, t equal to infinity is a part of a steady state. So t equal to 0 minus and t equal to infinite are the part of a steady state. So whenever they are asking anything at 0 minus or infinity, it means they are asking you what will happen at steady state. Okay, this point is very important. Also, t equal to 0 plus, the t equal to 0 plus is in a transient state. Understand this point? So this timing diagram is very important. Next. Now what will happen to energy storage element? The point is, what will happen of energy storage element at different time instant? We have seen 0 minus, 0 plus and infinity. So at these three time intervals, what will happen to different energy storage element, that we are going to discuss. So if you talk about, let me draw a table here. Here we will talk about inductor. Here we will talk about capacitor. Okay, and here we have a different time instant. Now first of all, what is Sir, why in a transient state was studied as 0 minus and 0 plus? Beta, because we have studied because of the energy storage element. For example, let's talk about someone push you. When someone push you, what will happen? First of all, you are not going to move forward. First, your body resists that particular push. That is known as the inertia of a body. Then that is actually resisting your push, but that will happen for a very very small amount of time. That as a human we cannot see that. Now the same thing happen for a network also. When the burst of energy is supplying because of the transient state, because of disturbance, then the particular energy storage element, which is capacitor and inductor, both of them resist that particular change. Both of them will resist that particular change, and because of that resistance exists only for a small amount of time. That's why we discussed the 0 plus. Now the question is, why the 0 minus? Because we have to compare our circuit ki what will happen before the switching or before the disturbance. That's why we discussed 0 minus also. Now here one point also. If you talk about capacitor, you know, across the capacitor, voltage remains same. It is very, very important equation. Also, through inductor, the current remains same. It is very, very important equation that across capacitor, voltage does not change suddenly. It will take some time to change. Across inductor, current does not change suddenly. Again, it will take some time to change. So these particular 2 points are very, very important. So in whole transient chapter, you have 4 equations, out of which these 2 equations are very important. And the first equation was the time constant. Now here, what will happen? If you talk about t equal to 0 plus, 0 minus, when you talk about 0 minus and infinity, it means we are talking about a steady state. Now I told you earlier, in a steady state, the inductor will behave like a short circuit and the capacitor will behave like an open circuit. Always remember, if you are going to study at 0 minus or infinity, you are studying at steady state. At this particular point, inductor will act like short circuit, capacitor will act like open circuit. Remember this point. Now, if you talk about t equal to 0 plus, t equal to 0 plus means just after switching. So t equal to 0 plus, the inductor will behave like a current source of magnitude IL 0 plus. Inductor, you can replace the inductor with a current source, and if IL 0 plus is 0, means inductor is not charged initially. Then in that case, what will happen? You will make a open circuit. Why? Because in a current source, if there is no current, it will act like an open circuit. Now what will happen here? The capacitor will behave like a voltage source. Of magnitude VC0 plus, and if VC0 plus is 0, then what will happen? It will act like a short circuit. It means if initial energy is not given or initial capacitor is not charged initially, then it will act like a short circuit. Finally, what will happen in transient time? If I ask what will happen in transient time, means I'm talking about this interval. What will happen in transient time? Then if you want to draw the circuit at transient time, you have to draw the circuit at Laplace transform. So for a Laplace transform, it will be LIL0 plus, and this will be SL. LIL0 plus and SL. Very, very important. In case of a transient time, you can replace the inductor with a Laplace transform. We have to draw the complete Laplace of a network. Once we draw the complete Laplace of a network, the inductor will be replaced like this. And what will happen to capacitor? And the capacitor will be like this. Okay, so this table is very, very important. Remember this thing. This table is very, very important. You need to remember this table because we are going to use this table in every question of transient. So we have 0 minus infinity, which is steady state, then at 0 plus, and this is inside a transient time. Any doubt till here? Tell me. If you have any doubt, you can ask. Yeah. Now I'm going to give you the flow chart how to solve the question. Let me give you the flow chart or steps to solve the transient question. So any question of transient, if you have any question of transient, the first step is to find initial condition. Any question of transient, the first step, find initial condition. If it is not given, if it is given, then okay. Find initial condition. Find initial condition. What is the initial condition? Inductor current at 0 minus and capacitor voltage at 0 minus. This is the initial condition that you have to find out. Why we can't change resistor? Because better resistor is not an energy storage element. Only the capacitor and inductor behave differently at different time instant. Resistor will not behave differently. It is just a particular energy absorption device. So if resistor is not opposing the change of energy, then why you are going to change resistor? Only the inductor and capacitor oppose the change. And how they will oppose the change? Because of this property. Because of this property that we have discussed. This property, because of this property, both of them will oppose the change that will occur in the circuit, but resistor does not oppose it. So where was I? First, any question of transient, the first step is to find out the initial condition if it is not given. Now after that you have to check whether you have a second order circuit or a first order circuit. If you have a first order circuit, then you have to check again. If you have a DC source, in that case, apply shortcut formula. If you have a DC source, apply shortcut formula. I will tell you what is the shortcut formula. If you have any other source, for example, exponential source, pulse source, or for example ramp so nahi hoga, exponential pulse source, then what you have to do? You have to apply Laplace method. Okay. Now in case of second order circuit, what you have to do? For analysis at t equal to 0 plus, we have to just draw network at t equal to 0 plus. For analysis at any other time, we have to apply Laplace method. I will explain each of these things. Okay? But a parabolic will not take it. We take the particular signal which is stable. Parabolic is not a stable signal. Or you can say bounded input. Parabolic is not a bounded input. That's why we are not taking the parabolic input or the ramp input, because we are talking about network having a stable circuit. So we have to provide the bounded input only, right? Now see very carefully what is this flow chart. It will help you to solve every question of transient. First of all, if you have any question of transient, the first step, find the initial condition if it is not given. After that, you have to check the order of a circuit. If you have first order circuit, then you have to check what is the DC source. If you have what is the source actually? If you have a DC source, apply the shortcut formula. I will tell you. If you have any other source, you have to change the complete network into a Laplace circuit and then solve it. In a second order circuit, if analysis is asking at t equal to 0 plus, if they're asking in a question anything at t equal to 0 plus, you just draw the network at t equal to 0 plus. And if they're asking anything else, for example, they are asking the equation of current or voltage at any time t, then you have to use the Laplace transform. If you talk about the exams, these two are most important. Means there is a 95% chance question will come only from these two topics. There are 95% chance. There is a hardly 5% chance the question will come from remaining two branches. Okay. Now let's talk about the shortcut formula. What is the shortcut formula? Shortcut formula tells you that voltage across any element is equal to V infinity minus V infinity minus V0 plus e raised to power minus t by tau. It means if you are going to find out voltage across any element, you can use this formula directly. What you need to find out? You need to find out time constant. You need to find out the time constant. You need to find out voltage at 0 plus and voltage at infinity. Only three things you need to find out, and you can put it in this particular formula. Otherwise, if you're going to a Laplace method, it will consume much amount of your time. So if you have a DC source, you can apply the shortcut formula, and just these three things you require. Now same goes for current. I infinity minus I0 plus e raised to power minus t by tau. E raised to power minus t by tau. Any doubt here? Any doubt till here? Okay. But remember, these two formulas are applicable for first order circuit and DC source. These two formulas are applicable for first order circuit and DC source. If you don't have a first order circuit or a DC source, you have to go for a Laplace transform. It's actually what formula you learn? You learn V infinity plus V0 plus minus V infinity, right? You use the plus here, I'm using a minus here. Formula is same. You're just using a plus here, right? I guess deleted the comment. Okay, coin. Okay, most of the time you remember the formula in which there's a plus sign here, so minus came. Okay, both formulas are same. So where was I? Next, these two are important. Next point. Change of inductor current at t equal to 0 plus is equal to inductor voltage at 0 plus divided by L. So if you want to find out change of inductor current at t equal to 0 plus, the simple formula is find out inductor voltage at 0 plus and divide by L. Same for the capacitor. Change of capacitor voltage at t equal to 0 plus is equal to capacitor current at 0 plus divided by C. So to find out change in capacitor voltage at t equal to 0 plus, so it will be IC 0 plus divided by C. Understood? Any doubt, Vadla? As yes, bro. Now I didn't understand your comment. If you have any doubt, you can ask. Okay, so this is the shortcut formula, and these two formulas which are going to use a lot in your exam, and this flowchart. Just remember this, and you can, and also this table. So just remember it, and you can solve every question of transient easily in a less amount of time. Okay? Any doubt here? Can we just start the question? Okay, so let's start the question. Let me solve the first question so that I will tell you how to apply everything that I have told you just now. So read the question carefully. The switch in the circuit in figure has been closed for a long time. Okay, and it is opened at t equal to 0. Find Vt for t greater than 0. Now understand here, you have a DC source, right? You have a first order circuit. So I can use the shortcut formula here. Okay. So we can use the shortcut formula here. Okay, but first you have to find out the initial condition. Now for initial condition means the switch has been closed for a long time. So switch has been closed for a long time. So it means I'm going to draw the circuit at t equal to 0 minus. Now remember the table. What will happen? At t equal to 0 minus, capacitor behave like a open circuit. At t equal to 0 minus, capacitor behave like a open circuit. This is 20 volt, 391. This is 3 ohm, this is 1 ohm, this is 9 ohm. And this is the initial condition I need to find out. VC0 minus. So what is VC0 minus? Can I apply the voltage division rule to find out voltage across 9 ohm? So 20 multiplied by 9 divided by 9 plus 3. It comes out to be 5 volt. So this is the initial condition we require. So any question of transient, the first step is to find out the initial condition. So if I have an initial condition, then I can also say VC0 plus is VC0 minus equal to 5 volt. The first step has been completed. Now they're asking voltage across the capacitor. So what can I use? I can use the shortcut formula. Voltage across capacitor is equal to VC infinity minus Vc infinity minus Vc0 plus e raised to power minus t by tau, है ना? Vc0 plus is already find out 5 volt. Now understand this thing. When the switch is opened, only this circuit remains. Only this circuit remains. It means capacitor is actually discharging. Capacitor is actually discharging. If you talk about till t tends to infinity, till t tends to infinity, the capacitor has been completely discharged. Capacitor has been completely discharged. So can I say Vc infinity is nothing but equal to 0? So Vc infinity we have. Now time constant. To find out the time constant, first I need to find out R equivalent. Now understand this point very carefully. For the time constant, when you find out the R equivalent, you find out the circuit after switching. So after switching, this particular network has been removed. So this will not come for a time constant. Remember this point, time constant is calculated for a circuit after switching. 15 volt आ गया? अच्छा. 20 into 9, 12. अच्छा 15 आएगा. Correct. Correct. Absolutely correct, बच्चा. 15 volt. ठीक है? Correct. हाँ. So we have to find out the time constant after switching. Okay. So what is R equivalent? You have to see from there. You have to see from here. It will be 1 ohm plus 9 ohm. 1 ohm plus 9 ohm. It comes out to be 10 ohm. So the time constant is 1 upon RC. So 10 multiplied by capacitance कितना है? 20 millifarad. 20 into 10 raised to power minus 3. So it comes out to be 5 seconds. है ना? इतने का ना? हाँ. It comes out to be 5 seconds. Now put every value here. So capacitor voltage is equal to Vc infinity 0. So if you put every value here, you will find out 15 e raised to power minus t by 5. This is the answer. This is the answer. है ना? So what we have done? We have used the table, we have used the flow chart, and we have used the shortcut formula. Okay? These three things you need to remember. Once you remember these three things, you can solve any question of transient. Just need to understand how to do the analysis, how to draw the circuit at t equal to 0 minus. Understood this thing? Now try this question. Try this question. Okay, we will do less number of questions, but we will try to do the every question which is unique. Now solve this question. See, step 1 already happened. Step 1 already happened because they have given you the initial voltage of 5 volt. Step 1 already happened. Okay? Next step, you have to check the order. This is the first order circuit. This is the first order circuit. Okay, it is also checked. But the source you can see, the source is exponential and impulse. The source is exponential and impulse. It means shortcut formula will not be used here. Shortcut formula will not be used here. It means shortcut formula will not be used here. So I can say shortcut formula will not be used here. So what we have to use? We have to use the Laplace. We have to use the Laplace. We have to use the Laplace. Try करो, Laplace use करो, Laplace use करो. Try it. We have to use the Laplace transform. अच्छा मैंने 1/RC यूज कर दिया क्या? अरे सॉरी. टाइम कांस्टेंट का फॉर्मूला क्या होता है? टेल मी. हाँ, माय फॉल्ट. थैंक्स. आई गेस माय फॉल्ट. यू आर एब्सोल्युटली राइट. R equivalent multiplied by C. So it comes out to be 1/5. So e raised to power minus 5. है ना? सही ना? करेक्ट? ठीक है. लेट मी चेक. मैंने यहाँ पर सही लिखा है. If I have done wrong here. अरे यहाँ पे भी रॉन्ग लिखते मैंने. सॉरी, माय फॉल्ट. रॉन्ग हो गया. RC होगा. सॉरी. इट विल बी R equivalent multiplied by C. करेक्ट. सही. Now try to solve this question. Try to solve this question. We have to use the Laplace transform. How we can use the Laplace transform here? Tell me. See, the Laplace transform means you have to convert the whole circuit into a Laplace circuit. How you can do that? What is the Laplace transform of this? What is the Laplace transform of tan e raised to power minus t ut? The Laplace transform is tan divided by s plus 1, right? So it comes out to be tan divided by s plus 1, right? Then I have a resistor here. Then I have a resistor here. There is no change in a resistor in a Laplace circuit. Now, what happened to a capacitor? I told you, we have connect a voltage source in series with a capacitor such that the voltage source is VC 0 plus by S. The initial voltage is 5. So it will be 5 by S and 1 by SC. So it comes out to be 10 by S. Finally, I have this also. This comes out to be 2. Why? Because Laplace of impulse is nothing but equal to 1. Laplace of impulse is equal to 1. Understood? Any doubt how to draw this circuit? Do you have any doubt how to draw this circuit? Tell me, guys. Do you have any doubt how to draw this circuit? Any doubt? What doubt, Rajesh? Tell me. What doubt you have in this circuit? Okay. So here I can say we need to find out V naught S. We need to find out V naught S. We need to find out V naught S. So in table, inductor, case current, source will come now. No, beta, that when you see the in inductor, that current source will come like this. Maybe you have learned about this table. If I am not wrong, you have learned about this table, right? What I have done, I have applied the source transformation there. Okay, in that way. And because there will be a voltage source that we are going to use, that's why I have told about voltage source. If you learn about the current source, that is also true. Okay, I just applied the source transformation there, nothing else. Got it? Yes or no? No? Okay. Now let's find out V naught S. So it is I1, it is I2, it is I3 or 2 ampere right? So I1 plus I2 plus I3 is equal to 2. So what is I1? V naught minus 10 divided by S plus 1 divided by 10 plus I2 is V naught by 10 plus I3 is V naught minus 5 by S divided by 10 by S equal to 2. Now simplify करना है तो पूरे को 10 से मल्टीप्लाई कर देते हैं तो it comes out to be V naught minus 10 divided by S plus 1 plus V naught plus कैलकुलेशन भी चेक करते हैं ना S times of V naught minus 5 equal to 20. ठीक है तो it comes out to be S plus 2 times of V naught 20 plus 10 times of S plus 1. Okay, कैलकुलेशन भी चेक कर लेना सही आ रही होगी वैसे तो 20 plus S plus 1, right? Now V naught is equal to 20 divided by S plus 2 plus 10 divided by S plus 1 S plus 2. Now you have to do the partial fraction. You have to do the partial fraction. That is important. So I hope you know how to find out the inverse Laplace. I hope you know how to find out the inverse Laplace. So let's do the partial fraction here. It will be 1 by S plus 1 minus 1 by S plus 2 and it will be 10 and 10. Understood? आता ना how to do the partial fraction. I hope you know how to do the partial fraction. अगर मैंने सही करा पहले मैं अपना देख लूं. S plus 2 minus S plus 1. हाँ करेक्ट सही है. हाँ तो this is the partial fraction. Now inverse Laplace. We have to take inverse Laplace. So if I am going to take inverse Laplace here, so what will be? It will be V naught t is equal to 20 e raised to power minus 2t plus 10 e raised to power minus t minus 10 e raised to power minus 2t. This is the answer. This is the answer. So in this way you apply the Laplace. In this way you apply the Laplace. So when you will apply the Laplace, when the shortcut formula is not applicable in a first order circuit, you can apply the Laplace in that particular question. Okay. Now in the same way you can solve the pulse type of question. If I'm not wrong, someone was asking pulse question before the break. If you have a pulse input, again, if you have a pulse input, for example, this is the input we have A till A. If you have a pulse input, again you can use the Laplace transform method only because it is not a DC input, but you should know how to find out the Laplace transform of it. How you can find out a Laplace transform of it? Can you write down? Vs is A times of ut minus u of t minus A. This is the mathematical representation of an equation. Now you just have to find out the impulse. You need to find out impulse or Laplace, sorry. तो 1 by s minus e raised to power minus as 1 by s, and then solve the question accordingly. ना pulse input नहीं direct delta नहीं आएगा, no direct delta will not come. Okay, side second line 5 is missing previous slide. अच्छा गलती कर दी क्या मैंने? अरे 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 नहीं कहा राइट साइड 5 ही ना बेटा 5 ही ना भानु, see very carefully 5 here ना. What I have done, I have multiplied by s also, है ना 5 here. हाँ बट प्लस नहीं किया मैंने, ओके माय फॉल्ट, प्लस नहीं किया, फाइन प्लस नहीं किया मैंने. 20 + 5 25 होना चाहिए. हाँ करेक्ट, कोई नहीं, ये तो आप इतनी कैलकुलेशन तो आप माफ कर सकते हो ना. 25 हो गया, दिस विल बी 5 here, करेक्ट. 25 + 10, तो बस आंसर में क्या होगा 25 आ जाएगा यहाँ पे. देयर विल बी 25 here, देयर विल बी अ 25 here, है ना. अंडरस्टूड, करेक्ट. फाइन. नेक्स्ट क्वेश्चन, try this one. The switch in figure has been closed for a long time. It is open at t equal to 0 and we need to find each of this part A B C D. Try करो. And I can see after break the students has been reduced. Always remember there is only a few students who can be concentrated till the end of a class, and that students only can have a good marks in the examination. Because जितना अच्छा आपका focus होगा और the time for your focus is very important, because when you start preparing for the gate examination, there are lakhs of students who start preparation for gate examination, but till the end of January or till the end of your exam, there are only few thousands which are left, which are still preparing for the examination. So always try to be in that particular range. So solve this question carefully. Solve this question carefully. The switch in figure has been closed for a long time. Now see very carefully. First of all, transient question, initial condition we need to find out, because initial condition is not given. Now they have said the switch is closed for a long time. It means the switch is closed. I am drawing the circuit at t equal to 0 minus. So at t equal to 0 minus, inductor is short and capacitor is open. Inductor is short, capacitor is open like this, and we have 12 volt plus minus 12 volt. And we have 4 ohm, we have 2 ohm. I need to find out inductor current at 0 minus, because we have both inductor and capacitor here, and capacitor voltage at 0 minus. So let's see, IL 0 minus. IL 0 minus will be equal to 12 divided by 4 plus 2. It comes out to be 2 ampere. If we talk about VC 0 minus, VC 0 minus is 2 multiplied by 2 is equal to 4 volt. So we have IL 0 minus and VC 0 minus. IL 0 minus and VC 0 minus. Now from there we can write down the condition that IL 0 plus is equal to IL 0 minus is equal to 2 ampere, and VC 0 plus equal to VC 0 minus is equal to how much? It comes out to be 4 volt. Okay. So first step has been completed here. So पहला step यहाँ पे complete हो गया. Now next we have to find out what? You can see we have a second order circuit. We have a second order circuit. Now in a second order circuit, I told you if anything is asking at 0 plus or infinity, no need to use the Laplace transform. So here we are not going to use the Laplace transform. We just need to draw the circuit at this particular instant. Now first of all, they are asking I 0 plus. Now this is the same current passing through inductor, so that we have already find out. I 0 plus is 2 ampere and V 0 plus is the voltage across capacitor. We have already find out. So first part is already done in a step 1. Now second, they are asking di by dt and dv by dt. Now di by dt is passing through inductor and dv is across voltage across capacitor. I told you how to find out this particular values. कैसे होता है? di by dt at t equal to 0 plus is equal to inductor voltage at 0 plus divide by L. Similarly, dv by dt at t equal to 0 plus is equal to capacitor current at 0 plus divide by C. So remember this point. This point is very important. So we have to find out inductor voltage and capacitor current at t equal to 0 plus. So I will draw my circuit at t equal to 0 plus. So understand this thing very carefully. Use the table. At t equal to 0 plus, inductor behave like a current source. This switch has been opened, so 2 ohm will not come in picture, and the voltage act and the capacitor act like a voltage source, and capacitor act like a voltage source. This is plus minus 12 volt. This is 4 ohm. This is 2 ampere, and this is 4 volt. So I hope you know how to draw this circuit. How to draw this circuit. Okay. Now from here, we need to find out inductor voltage. We need to find out inductor voltage from here, plus minus VL 0 plus, and we need to find out the capacitor current at 0 plus. So what is the capacitor current at 0 plus? Capacitor current 0 plus equal to the current source 2 ampere. Equal to the current source 2 ampere. Understood? Yes or no? Polarity I have given wrong. This is the wrong polarity. No, wait a sec. This is the wrong polarity. Now apply the KVL. It will be minus 12 plus 4 multiplied by 2 plus VL 0 plus 4 volt equal to 0. Yeah? So it will be 4 to the 8 for the 12. So VL 0 plus comes out to be 0. VL 0 plus comes out to be 0. VL 0 plus comes out to be 0. Now find out the answer. What is di by dt? It is equal to, what is di by dt? It is equal to 0. And what is this? IC 0 plus. It will be 2 ampere divided by capacitance, which is 0.1. So answer is 20 ampere, 20 volt per second, 0 ampere per second. Yes or no? Understand this thing? 20 ampere and the 20 volt per second and 0 ampere per second. Understand this thing? Yes or no? Tell me. Now we have to find out I infinity and V infinity. Again, I have to draw the circuit at t tends to infinity. So at t tends to infinity, what will happen? The inductor act like a short circuit. Capacitor act like a open circuit. And already the switch has been opened here. We need to find out current infinity. We need to find out I infinity and V infinity here. And this is nothing but equal to 12 volt. This is nothing but equal to 12 volt. So I can say, what is I infinity? It is 0. What is V infinity? It is 12 volt. Khatam question. Finish. The question is finished. I0, V12. Absolutely correct. Okay. So again, in this question, what we have seen, the second order circuit in which there is a 99% chances that if the question comes from a second order circuit, they are going to ask you these three only, nothing else. Okay. There is a very, very less amount of chance that they will ask you the current equation or voltage equation. But if they ask you, then you have to use the Laplace transform again. Okay? That's why Laplace की practice कर लेना. It will help you a lot to practice the Laplace question. Now let's solve one more question. Try to solve this question. So we have given two capacitors, 1 microfarad, 2 microfarad, in which first capacitor is initially charged to 6 volt. Second capacitor is initially charged to 2 volt. The switch has been closed at t equal to 0. So you need to find out capacitor voltage across at 0 plus and also at infinity. 0 plus and infinity. My world has given the answer of previous question. Sahi hai. Correct. Absolutely correct. To find out this thing, try karo. Try this. अच्छा question है. This type of question has come alternate year in your GATE examination in both electrical and EC. Anyone? See very carefully. See very carefully. What will going to happen in this circuit? Listen very carefully. Listen very carefully. You can see the C1 has been charged to some higher potential. C2 has been charged at lower potential. Okay? When the switch will close, the C1 start to discharge and C2 will start to charge. है ना? So when C1 is discharging, C2 is charging. Now when it is discharging, it is charging. They will come at a common voltage, and when they will come at a common voltage, the potential difference between them becomes zero. Since the potential difference is zero, there will be no flow of current or no flow of charge, and hence the particular voltage will be the final voltage. So what will happen in this particular circuit? When the switch is closed, C1 start to discharge, C2 will start to charge, and once they reach the common voltage, there will be no flow of charges after that. There will be no flow of charges after that. Now from this point, two more questions will arise. The first question, what will be the current that will flow in this circuit? Or I will ask you, what will be the shape of a current? What will be the waveform of a current that will flow in this circuit after closing the switch? Now understand this point very carefully. Understand this point very carefully. There is no resistor present in circuit. There is no resistor present in circuit. It means if there is no resistor present in circuit, then charging and discharging will occur instantaneously, because that time constant becomes zero. If you see this circuit carefully, you will check that time constant approach to zero, and time constant tells you the speed of charging and discharging. Since the time constant approach to zero, the particular charging discharging will happen instantaneously. It will not take any time to charge and discharge or to reach the final voltage. It will take no time in charging, discharging and reach to the final voltage. It means the current which is going to flow in this circuit, the current which is going to flow in this circuit will be the impulse current. The current flowing in this circuit will be the impulse current. Remember this point. Why the impulse? Because the charging discharging happen instantaneously due to the absence of resistance, and hence the current flow will be impulse. Very, very important. Impulse. Now, if the current or charges are flows in impulse, then understand this point carefully. In this particular question, in this particular circuit, VC0 plus is not equal to VC0 minus. Here, the VC0 plus is not equal to VC0 minus because everything happened instantaneously in a very, very small amount of time. As soon as you close the switch, the final or steady state will reach. So whatever you are asking, whether it is 0 plus or whether it is infinity, both will have the same answer. Both will have the same answer, because as soon as you close the switch, everything will happen in that particular instant, and your charges flow will be stopped. Okay, so this point is very, very important to learn. Now next, how to find out this? If it is not applicable, then how to find out this? Using the charge conservation method. Charge conservation principle is the principle which can never be failed. Charge in every circuit, there will always be a charge conservation. Anything can be failed, but the charge conservation principle can never be failed. Charge conservation principle tells you that charges remain constant at any given time. This point is very important. It means let me do another page. It means charges at infinity is equal to charges at 0 minus. Charges at infinity is equal to charge at 0 minus. Charge conservation principle we have. Now what is the formula of charge? At 0 minus, charge is C1V1 plus C2V2. Now at infinity, what is going to be a charge? The circuit has become this. The circuit will have a constant voltage V, C1 and C2. So I can say it become V C1 plus C2. Both will have a same voltage. Understand? As soon as you close the switch, this particular condition will reach. So either you are asking at 0 plus or infinity, you are getting a same voltage. So from here, V comes out to be C1V1 plus C2V2 divided by C1 plus C2. Now in the question, C1 was how much? 1 or 2? 1 or 2. So we have 1 into 6, 2 into 2 divided by 1 plus 2. So it comes out to be 10 by 3 volt. It comes out to be 10 by 3 volt. So this is the answer. This is the answer for VC1 0 plus. This is the answer for VC2 0 plus. This is the answer for VC1 infinity. This is the answer for VC2 infinity. VC2 infinity. So this is the answer for all of these things. Okay? Understood this point? Shivani, no, the power electronics is not for EC. Power electronics is not for EC. Okay, so this is the answer. Understood this question? Understood this question? In the gate examination, they have already asked you, in the same question, they have already asked you what will be the current waveform. So the answer was impulse. Now this is the extension question. If they ask you the voltage, you have to solve it like this manner. Okay. Okay. So transient सही है इतना? तो याद रखो, in the case of transient, once again, Valda, what point you didn't understand? Otherwise, you can again watch the particular section of video. But if you have any doubt in any of these points, you can ask. Now, what we have already seen the 3 to 4 questions of transient, bachcho. So for a transient, what you have to do? First, you need to remember the table, the flow chart, shortcut formula. Okay, these 3 things. Next, practice more and more question on the Laplace transform. If you practice 5 to 6 question, चाहे वो previous year ही क्यों ना हो, practice 5 to 6 question of previous year, you are going to get the Laplace transform method easily also. But remember, Laplace transform method, when they will give you, then they will ask you to that method, the circuit will be very simple. Because in a complex circuit, it is very difficult to apply Laplace and then find the inverse Laplace. Okay, and I am hoping that you know how to find out a Laplace transform of any signal, because it is a very basic thing for the electrical and EC student. You use the Laplace in case of signal system, control system, machines, power electronics, power system. So it is a very basic thing to find out Laplace transform. Okay, so next we can go for a 2-port network. Can we go for a 2-port network? Enough. So 2-port network start karte. So in case of 2-port network, it's very simple. 2-port network is very, very simple concept. The easiest chapter you have is a 2-port network. There will be some calculations that you can get, but conceptual wise, it is very easier chapter. Now, what is a port? Port is a combination of terminal. Port is a combination of terminal in which you can apply the signal, also from where you can take the output. Are there AC circuits after this? Where you can apply the input and take the output. Now, in a 2-port network, you have a 6 parameters. In a 2-port network, you have a 6 parameters. Now, the one point here, these are the conditional parameters. These are the conditional parameters. What is the meaning of conditional parameters? That when you find out the value of these parameters, you have to put some condition, like the input port is open circuit, yeah, output port is open circuit, or port 1 is short, anything else. You are applying some condition to find out the parameters. That's why it is known as the conditional parameter. Next point, it is only applicable for linear circuits. It is only applicable for a linear circuits. If you have a non-linear circuit, you cannot use the 2-port method. That's why you have seen, if you have done the analog electronics. So in analog, what happened? In a small signal analysis, we use the H parameter, because for a small signal analysis, transistor behave like a linear device. But if you see the large signal analysis, we cannot use the H parameter there, because for the large signal, the transistor behave like a non-linear circuit. Okay, that's why in a small signal, we use H parameter. Okay, so in 6 parameters, they are using conditional parameters. Also, linear circuits will be applied here. Okay, now what are the 6 parameters? Now remember, all the parameters that we are going to see, this is going to be the network. This is V1, I1 is entering. This is V2, I2 is entering. Okay. Now what are the parameters? Everybody knows? Yes or no? Sabko pata hai? What are the parameters? For example, this is the Z parameter. This is the Z parameter. This is the Z parameter. Now what you need to remember? You need to remember this only. You need to remember this only. Once you remember this, or I can say you need to remember equation only. For a Z parameter, the equation is V1 Z11 I1, Z12 I2, Z21 I1 plus Z22 I2. You only need to remember this equation. After it, you can easily find out each parameter. Okay. For example, if you want Z22, you can say that I1 should be 0. You can say I1 should be 0 and V2 divided by I2. So V2 divided by I2 gives you the Z22. So once you remember that equation, you can easily form this particular conditions also. Now I1 equal to 0 means port 1 open circuit. Port 1 open circuit. Because when you do the open circuit, then only the current will be 0. When you do the short circuit, the voltage is 0. है ना? Same case for Y parameter. Same case for a Y parameter. You only need to remember the equations here. For example, if I say what is Y12? Y12 is equal to I1 by V2 when V1 is 0. V1 0 means port 1 short circuit. But yes, you have to remember this equation. There is no shortcut of remembering this equation. Okay. Now tell me one point here. Can I say this thing that Z11 is equal to 1 upon Y11? Can I say this thing? Z11 is equal to 1 upon Y11. You can see the Z parameter here and you can see the Y parameter here. So can you say the Z11 is equal to Y11? Manasuri said yes. Anybody else? And I can see the watching is again down. इसलिए लंच पे नहीं जाना चाहिए था. एक सेकेंड. हाँ. Yes, Ashok said no. Anybody else? Yes, the answer is no. Why? Listen very carefully. When you find out the Z parameter or when you find out Z11, what is the condition? That I2 is 0. When you find out Z11, condition is I2 0. When you find out Y11, condition is V2 0. Since conditions are different, they are the particular parameter or element are not reciprocal of each other. Remember this thing. Z11 is not equal to Y11. Remember this thing. Because the conditions are different. But the Z parameter and Y parameter are linked by inverse. The matrix are linked by inverse. So Z matrix is equal to Y inverse. Understand this thing? Okay? Admittance. Now, before going further, let me ask you one more thing. अच्छा. Okay, इतना हो गया. Any doubt here? Now next, we have a H parameter. Again, remember this equation of H parameter. H is the hybrid parameter because they interlink both voltage and current. So it is a hybrid parameter. So just learn about the H parameter. So in the H parameter, here you can see, for example, I need to find out H21. It will be I2 by I1 when V2 is 0. Now V2 0 means port 2 is short circuit. Telegram link for PDF. You can search electrical and electronics by Ishan Mudgal. Or I will send the link. Wait a sec. I guess I cannot send the link here. But you can search electrical and electronics by Ishan Mudgal. You will get the particular telegram. So H parameter, H21 is equal to I2 by I1. Next, ABCD parameter that you need to remember. Now, understand one point carefully for the electrical students. Listen very carefully. The ABCD parameter that you use here, for this particular network, in which I2 is entering, or I can say both I1 and I2 is entering. For this particular network, this is the ABCD parameter where you will get minus sign with I2. Understand this point carefully. But in power system, because ABCD parameter you learn in power system also. So in power system, we have this network. In power system, we have a receiving side and a sending side. So I1 and I2. So in power system, you learn this ABCD parameter. Where there is no minus sign. So for the electrical student, you have to check what is the direction of current given. If the question is from the network theory, you can use this particular ABCD parameter. If the question is from power system, you have to use this ABCD parameter. The only reason is that because in power system, the receiving side does not provide energy to the source. That's why the current can always flow in one direction. Whereas in network theory, you can also apply source here and load here. So because of that point, current can also enter into a network. Okay? But for the EC student, you can directly remember the minus here. No problem here. Okay, understood? So first point in a two-port parameter is that you have to learn each and every equation. Z, Y, H and T. Only these four are important. Remaining G and T dash parameter, they are reciprocal of them. For example, here I can say the G parameter is equal to inverse of H parameter. Okay, similarly here I can say T dash parameter is inverse of T parameter. ABCD parameter also known as the T parameter. Okay, understood this point? Now the question is how to solve the question. Yeah, the problem where most of the students occur key how to solve the question of two-port network. So let me tell you, listen very carefully. Whenever you have a two-port network, you have to check the particular network which is given. If the network is simple, means that according to your perception, if the network is simple, then what you have to do? You have to apply the condition. You can apply the condition, for example, I1 equal to 0. So you will make the port 1 open. When you make the port 1 open and draw the circuit and find out whatever you can find out from there. Similarly, you can apply the second condition and find out the output. So in case of simple or complex, whatever circuit you have, you can apply this particular conditions. The another method is find out all the KCL and KVL equation. Find out all the KCL and KVL equation, and after finding out those equation, you need to put the value of I1, I2, V1, V2 according to parameter that you need to find out. Okay, but I will advise you one thing. When you have a complex question, the easier way is to apply the condition and draw the circuit again. If you have a simple question of one mesh, two mesh, if you have a simple question, find out all the KVL, KCL equation and then put the condition. Okay. So let's solve one question over this. But before that, we have 2 points. We have the condition of reciprocity and symmetrical. Now, what is the meaning of reciprocity? Reciprocity means the particular system which follows the reciprocal theorem. That follows the reciprocal theorem. Also, the reciprocity means that if you provide the input at either side, or you can say if you interchange the load or if you interchange the source at either side, the ratio of excitation to response remains same. So that is the meaning of reciprocity. So if the network is reciprocal, then these conditions must be satisfied. Okay, you have to remember this condition. Mansuri, that is transmission parameter. T parameter is transmission parameter. For Y also, we have Y12 equal to Y21. If you have a symmetrical network, symmetrical means that if you draw a one particular line, the particular network will divide into a mirror image of it, or you will get an equal network on both sides of a axis. That is known as a symmetrical network. So if you have a symmetrical network, then these conditions must be satisfied. Also, we have Y11 equal to Y22. So yes, you have to remember this condition. It is very, very important for you. Okay, question will come directly from this, whether you have to identify, or they will give you a circuit which is actually a symmetrical. Then you only need to find out Z11. No need to find out Z22 separately, because if you know the network is symmetrical, then it is easier. Now again here, passive network always follows this condition. Passive network always follows these conditions, because I told you earlier also, passive network is always a reciprocal network. They always follow the reciprocity theorem. So if you have a passive network, this condition will always follow. Okay, understood? Now let me give you one shortcuts also. Let's talk about the shortcuts. if you have a t parameter, like this, z1, z2, z3, then you can directly write down the z parameter. What is here? It is z1 plus z3 principal diagonal. The second principal diagonal is z2 plus z3. Here non-principal diagonal are equal and equal to z3. So this is the shortcut method. So if you have a t network, you can directly find out a z parameter without going through any equation. What you have to do, in a principal diagonal you have a z1 plus z3 and z2 plus z3, and a non-principal diagonal is a common element. Okay? Now if you talk about the pi network, for a pi network, what you should have to do? You should have a admittance here. For a pi network, you should have admittance. So for a pi network, what is the shortcut for y parameter or admittance parameter? It is y1 plus y3. Next principal diagonal is y2 plus y3. And non-principal diagonal is minus y3. Okay, remember this. You need to remember this. Important. If you see the previous year question, the 30% question just based on these two circuits. Now how you can use it? For example, they're asking you to find out the h parameter of this network, of delta network. So what you can do? You can find out a y parameter and then transform it into h parameter. Similarly, if they're asking the y parameter of this circuit, what you can do? Find out z parameter, transform it into a y parameter. So it will reduce your time a lot. Okay, complexity of a calculation will reduce a lot if you remember this two particular shortcuts. Okay. Now let's solve this question. In the two-port network shown, the H11 parameter in ohms is. So we only need to find out H11. Sir, we have to, it's reciprocal. I think you can say one thing here, that these two networks are always reciprocal. You can say these are always reciprocal. That's why you can see the that's why you can see the conditions are also satisfied. Here you can see conditions are also satisfying here for the reciprocal network. So these two networks are always reciprocal. Now in this question, you only need H11. If you only need H11, why you go and find out all the KCL KVL equation? You only need H11. So just applying the condition here. How you will apply the condition? We need to find out H11 at which V2 is 0. V2 means short circuit. So I'm going to do the short circuit here. And I need to find out ratio of V1 and I1. So let's find out how you can solve this question. Let's see how you can solve this question. Think about it. V20 means short circuit here. V20 means the short circuit here. How you can solve this question? Simple hai. Dekho. Assume the current here is I. Then how much current is coming from, or I can say how much current is going from here. I1 is coming, I is going, 2I is going. So I can say I plus I is coming here. Simple. है ना? Apply the KCL. I1, So I1, 2I1 and I will going out. So I can say like this. So I1 plus I coming, 2I1. So yeah. So can you distribute the current like this? Using the KCL, I have just applied the KCL method to distribute the current. Now mark the polarity. It is plus minus. Now I'm going to apply KVL in 1. So if you apply the KVL in first equation, it will be 1 multiplied by I1 plus I equal to 0. So from here, I comes out to be minus I1 by 2. Okay? Now apply the KVL in 2. So if I apply the KVL in second equation, in this loop, so I will get V1 is equal to I1 multiplied by 1 plus I multiplied by 1. Right? So if you put the value of I, it will be minus I1 by 2. It comes out to be I1 by 2. So from simple here, I can say H11 is V1 by I1 is equal to 1 by 2 ohms. Simple. है ना? Simple. 1 by 2. It comes out to be 1 by 2 ohm. Simple. Any doubt? Any doubt in this question? So this is the easier way. This is the easier way to find out. No need to write down all the KCL, KVL equation. You can also simplify like this. Next. Try to solve this question. Try to solve this question. We need to find out Z parameter here. We need to find out Z parameter here. Wait a sec. Okay. We need to find out Z parameter here. How I1 plus I in 1 ohm. KVL apply किया ना बच्चा? Which I1 plus I. See ना, we hear carefully. But we have applied the KVL here. So there is a plus polarity. So 1 multiplied by I1 plus I multiplied by 1. So then we apply the KVL. Understood? Simple Ohm's law. Simple Ohm's law. Now how to solve this question? How to solve this question? Simple है. We are going to apply the star delta transformation. We are going to apply the star delta transformation. That you can do it by yourself. I'm giving you the shortcut trick. Okay? You can apply the star delta transformer yourself. So the circuit will become like this. The circuit will become like this. Let's suppose this is R3. It is R2. This is R1. This is 1. The circuit will become like this. I hope you find out R1, R2, R3. Then what is the Z parameter? What is the Z parameter? Shortcut formula, because you have a T network. So the shortcut formula you can apply. 1 plus R1 plus R3. Here it is R2. It is R2. It is R2 plus R3. Yes or no? Yes or no? Can you find out like this? Tell me, bachcho. Can you find out like this? Once you have converted the star, once you convert delta into a star, then this becomes the complete star. If this become a complete star, I can apply the shortcut formula directly. Okay, understood? है ना? अच्छा, R2 plus R3, हाँ, there will be R3. Common element R3 है ना? Sorry, हाँ, you're right. Common element is R3. Common element is R3. So it will be R3, R3. Okay. Now, this question you can solve it. Let me tell you one more thing. Change of parameter. Change of parameter. See, one thing you know, that Y parameter is inverse of Z parameter. Okay. H parameter is inverse of G parameter, and T parameter is inverse of T dash parameter. So these three relations are easier to identify. These three relations are easier to identify. If you have a Z, you can find out Y. G, you can find out H, and vice versa. But my question is, how will you find out H parameter if the Z parameter is given? If Z is given, then how you will find out H parameter? Tell me. The one method is that you have to remember all the formulas. There are many formulas there. So one method is there, you can remember all the formulas. So that particular formulas you can find out easily on the net. So you can remember formulas and put the formulas directly there. But there is another method which is a mathematical method. So I'm going to discuss that method with you. Okay? To understand that method carefully. For that, I am taking one example. I'm assuming that Z parameter is, I'm taking one example that Z parameter here is equal to 1, 2, 3, 4. Okay. And I need to find H parameter. The particular steps that I'm telling you, that is only applicable if you want to convert parameter apart from this. If you want to convert the parameter only in these three cases, then you can do it by taking inverse. But the method I'm telling you is only applicable for other transmissions other than these three. Okay, so let's find out first. What is the first step here? The first step is write given parameter, right? Given parameter into equation form, right? Given parameter into equation form. So as that parameter is given, so I can write down v1 v2 is equal to I1 plus 2 times of I2, 3 times of I1 plus 4 times of I2. So first write down the given parameter into equation form. Second step, write equation form, right? Equation form of desired parameter. Now what is desired parameter? H parameter. Desired parameter. Now what is the desired parameter? H parameter, है ना? So for a H parameter, what is the relation? V1 I2 is equal to H11 I1 plus H12 V2, H21 I1 plus H22 V2, है ना? This is the desired, this is desired. Now understand. Now listen next point very carefully. Listen next point very carefully. You need to check which two equations are common in these. You need to check which two equations are common in this. If you see, the equation here is V1 I1 and I2. Here the equation is between V2 I1 and I2. Here the equation is V1 I1 I1 and V2. And here the equation is between I2 I1 and V2. Here the equation is between I2 I1 and V2. So tell me which two equations are common. Which two equations are common? You can see this is between I2 I1 V2. This is also between I2 I1 V2. So these two equations are common. So what is the step 3? Step 3. Find common equation and rearrange it. Find common equation and rearrange it. So this is the common equation. I am going to rearrange it into this form. We can do the rearrangement. कुछ भी देना mathematical operation है. If you are going to rearrange this, you will find out minus 3 by 4. If you rearrange this, you will find out minus 3 by 4 I1 plus V2 by 4. Yes or no? If you rearrange this, you can find out this equation. 3I1 इस साइड आ गया, minus 3I1 has been shifted here, divide by 4. So now this equation that has been coming out after rearrangement and this equation both are same. So you can say directly that H21 is equal to minus 3 by 4 and H22 is 1 by 4. H22 is 1 by 4. Okay. So one thing we have already find out. What is the step 4? Put rearrange equation into remaining equation. So what is the rearrange equation we have? This is the rearrange equation we have now. Now I will put this equation into this one. Why? Because I need equation between V1, I1, V2. So if I put I2 here, the equation comes out between V1, I1, V2. Right? Understood this point? Now if you put the equation here, so V1 I1 plus minus 3 by 2 I1 plus V2 by 2. So after solving, it comes out to be minus I1 by 2 plus V2 by 2. So from here, H11 is minus 1 by 2, H12 is 1 by 2. Like this. Understood here? Yes or no? In this way, you can convert one parameter into another parameter without remembering the formulas. You just need to remember this step. Any doubt here? You can ask. If you have any doubt, you can ask. Okay? And if you understand this concept, then say okay, sir. Wait a sec, guys. अरे कहाँ गए? सो गए क्या सब? Everybody slept. Okay, fine. So without remembering the formulas, you can solve like this. Okay, well done. बढ़िया. Okay, now this question you can solve it by yourself. Okay, you can practice more and more questions. If you have any doubt, you can ask the question directly to me. But try to solve more and more questions. Okay. Now we are going to see Want to solve this question? Now let me tell you idea behind this question. Sir, please explain the step 4. Sir, please explain the step 4. But what I have done in a step 4, why I have done in a step 4, this is the rearranged equation I have now. I just put this rearranged equation, in the remaining equation. This remaining equation, just. And it is applicable for every transmission. So I just put this particular relation into this. So when I put in this, I got the answer like this. Okay. Black box wala? Haan, this is the question of black box. This is the question of black box. Now, there are multiple methods to solve the black box question. I will tell you the method that I feel is easier. I'm not saying another method is difficult, but let me tell you, one method is that if you are given a black box, you can create a network here. But that method is only true if you have a Y parameter, Z parameter, or H parameter. In case of ABCD parameter, you cannot create a network. So that is only true for them also. So the one method, no, my fault. हाँ, नहीं सही. So one method is to create a network here. Okay, one method is that. Second is the mathematical method. You just have to use the equations and you have to rearrange the equations. And rearranging the equations somewhere, you will find out it will a bit complex, but it is very much easier as compared to the another method. Okay. For example, in this question, what we need to find out? V2 by V1. I need to find out the ratio of V2 by V1. What you have to do? First of all, write down the equation of the network which is given. You have given the Y parameter. Write down this equation first. The पहला step क्या होगा? Step 1. Step 1. Write given parameter. Given parameter into equation form. ठीक है? So Y parameter given ना, तो I can write down I1 is equal to 0.1 V1 minus 0.01 V2. Next we have I2 is equal to 0.1 V1 plus 0.1 V2. है ना? पहला step ये हो गया. ठीक है? Very much easier है. Just you have to rearrange the equation. First step is this. Now what is happening? You need a 4 equation because you have a 4 variable. What are 4 variables you have? I1, I2, V1, V2. So basically you require a 4 equations here. So this is the first equation. This is the second equation. Now next you can see one equation can be formed from here. You can apply the KVL and one equation can be formed from here. Okay, let's draw the equation. So minus 100 plus 25 I1 plus V1 equal to 0. So I can say V1 plus 25 I1 is equal to 100. This is the equation number 3. V1, 25 I1. Equation number 3. Now next equation you can see I2. I2 is going in this direction. So can you say what is V2? V2 is minus 100 times of I2. So V2 is minus 100 times of I2. So now you got 4 equations. This is a common step in each and every black box question. This is going to be a common step in each and this is going to be a common step in each and every black box question. Okay? Now after that you have to see what you need to find out in a equation. In a question. In a question you need to find out ratio of V2 by V1. So using these 4 equations, find out the ratio V2 by V1. Now that you have to do mathematically. कैसे होगा? See very carefully. I know V2 is in terms of I2. So if I am able to find out V1 also in terms of I2, then it will become very much easier. Or there is some another method. So you should tell me, you have a 4 equation here, how you will find out the ratio. You have a 4 equation here, how you will find out the ratio. Think about it. Just 4 equation you have and you need to solve it. What you can do? See, if I put equation 4 into equation 2, put 4 into 2. So it will be I2 0.1 V1 plus 0.1 minus 100 times of I2. So I2 equal to 0.1 V1 minus 10 times of I2. So here I can say 11 times of I2 is equal to 0.1 V1. I can say like this. I can say like this. Now I have this equation, V1 in terms of I2, V2 in terms of I2. Just divide them. Khatam ho gaya. Just divide them. So, or you can also write down V1 is equal to 1110 by I2. ऐसे होगा ना? V1 is equal to 1110 by I2. If there is some calculation mistake, you can tell me. So what we have to find out? V2 by V1. So V2 is minus 100 and this is 110. So it comes out to be minus 10 by 11. It comes out to be minus 10 by 11. Option D is the right answer. Minus 10 by 11. है ना? देखो, what do you, again I am going to repeat it. In every black box question, the first 2-3 steps are same. First, whatever the equation is given, write down. Then after that, whatever the remaining equation you can form that remaining equations. For example, here I can form the remaining equation, these two meshes. Okay. After that, you have to solve those 4 equations that you can do by your perception कि आप कैसे networks को देखते हो, equations को देखते हो, and then solve it. In this way, you can solve the black box question. Understood? Now, for example, in this question, in the same question, they ask you what is the Thevenin's voltage. In this question, if they ask you what is the Thevenin's voltage, though use your mind. In the Thevenin's voltage, you remove the resistor. You remove the resistor. So when you remove the resistor, the I2 becomes 0. I2 becomes 0. So can you put I2 0 here? Once you put I2 0 here, find out the V2. Once you put I2 0 here, find out the V2. So in that sense, you can find out the Thevenin's voltage also. Now, if they ask you what is the Thevenin resistance in this case, now how do you find out? How you find out RTH? In the RTH, you can use the test source method. कैसे? Just remove this particular 100 volt, short circuit this 100 volt, short circuit this 100 volt, apply the 1 volt here. If you apply the 1 volt here, so V2 become the 1 volt and I2 you need to find out. Now using the equations, put these values there. RTH comes out to be V2 by I2. RTH comes out to be V2 by I2 or 1 by I2. Okay. So in every black box question, first form all the equations you can. After that, you can put the conditions, whatever they are asking. In this, they are asking ratio. Sometime they can ask you VTH, RTH. Understood? समझ गए? Okay. Now let's go for next topic. Conversion, I already told you. This I told you. Now we'll talk about the AC circuits. Any doubt here? For example, in last question, you need to find out RTH. VTH will be 0 here because this question is not asking about VTH. Let's talk about RTH here. Let's talk about RTH here. Let's talk about RTH. So for a RTH, this will be the circuit because the independent source has to be short circuit. Independent source has to be short circuit and you need to apply the 1 volt here. You need to apply the 1 volt here. So this will be the circuit 25 ohm plus minus V1. Okay? This will be the circuit here. So here you can say V2 is 1 volt. V2 आपका 1 volt आ गया. V2 is 1 volt. Now what you need to find out? You need to find out I2. You need to find out I2. So earlier equation क्या थी? We have this equation. V2 is equal to, no need to do that. No need to do that. You can again form the equation here. You can again form the equation here. कैसे? Two equation is already given. Two equation is already given, which is Y parameter. So Y parameter is already given. What is the equation? 0.1, 0.1. So 0.1 V1, 0.1 V1 minus 0.01 minus 0.01 V2 and plus 0.1 V2. Now, these two equations are already given. First of all, next one equation you can say write down that V1 is equal to minus 25 I1 and next V2 is equal to 1. So these 4 equations you have, you need to find out I2. You need to find out I2. कैसे find करोगे? Use your brain. You have these 4 equations. You need to find out I2. How will you find out I2 here? First of all, if you put V2 equal to 1, then you can find out I2. Yes or no? Let me check. V2 equal to 1 put करोगे ना? So think about it, how you can find out I1. Simply, you have a 4 equation. By substituting the equations, you can find out I2. Since this question is not for the Thevenin's, this question is not for the RTH. I am just telling you about the simple concept here. Okay? So here after that RTH will be 1 by I2. अर्थ को आ गया. Okay, next. Now let's talk about the representation of AC quantities. Now we will talk about the particular AC circuits. So before going to AC circuits, there are few points that you should first know. Then only you can solve the question based on AC. Okay. First of all, we have 4 quantities based on AC. We have a voltage, we have a current, we have a impedance, we have a admittance. So these are the 4 quantities we have. Okay. Now voltage and current. First of all, tell me, what do you mean by phase? What do you mean by phase? First of all, tell me, what is the meaning of phase of a signal? What is the meaning of phase of a signal? For example, we say 30 degree, we say 60 degree. What is the meaning of phase of a signal? Angle. वाह, तो वो तो मैं नहीं बोला. Definition. Phase of a signal. It is the angular displacement. It is the angular displacement of signal from origin. It is the angular displacement of a signal from origin. That is the meaning of phase of a signal. Angular displacement of a signal from the origin. Okay. Now, how will you represent voltage and current? When you have a voltage and current, the represent are done in 3 ways. That we say the phasor representation. We do the phasor representation. Let me show. This is not a phasor representation. Okay. So when we have a voltage and current are known as a phasors quantity because of the phase they can provide. That's why they are known as a phasor quantity. So there are 3 methods to represent a phasor quantity. Phasor quantities. One is a rectangular form, one is a polar form, one is an exponential form. Exponential form is not that much useful, but rectangular form and polar form are very, very important. Why? Let me discuss that point. For example, I have a signal x is equal to a sine omega t plus phi. Now let's talk about this signal. What is A? A gives you maximum amplitude. A gives you the maximum amplitude. This is frequency. And this is actually a phase. This is frequency and this is actually a phase. Okay, understand this point. Now next point here. I want to convert, this is the rectangle, this is the trigonometric form. Now I need to convert this into a polar form. Also known as a phasor form. So if I convert this into a polar form, so I can write down x is equal to a angle phi. You can write down x equal to a angle phi. Now remember one thing carefully. You can also convert this like this, or you can also write down a by root 2 angle phi. When you write down a by root 2 angle phi, so this tells you the RMS value. But when you are using a angle phi, then this is actually a maximum value. So this is very, very important to understand कि in which form you are converting, RMS or maximum. Both are correct, but the calculation will be changed according to that. For example, suppose that I have a network in which I have applied the voltage 6 angle 30 degree, है ना? And because of that, current comes out to be 4 angle 10 degree. Because of that, current comes out to be 4 angle 10 degree. Now the point here that I'm going to explain you is, the point here is that, what is 4? Is this the maximum value or RMS value? Tell me, what is 4? It is the maximum value or RMS value? Think about it. 4, it is a maximum value or the RMS value? It is a maximum value or the RMS value. So listen very carefully. By default, if nothing is mentioned, by default, RMS. by default, if you have R angle phi, then this represents RMS value. Remember this point by default. Okay? Now the second point. If this is maximum, then output is also maximum. If this is RMS, then output is also RMS. So remember this point. If in a signal you have mentioned that input is maximum, then output will be maximum. If the input is in RMS, then output is in RMS. If nothing is mentioned, then by default you have a RMS value. Okay? Now polar form we have converted. Now what is the rectangular form? How to convert polar into a rectangular form? Let me tell you. For example, I have R angle phi. How I can convert this into a rectangular form? R cos phi plus iota sin phi. So it comes out to be R cos phi plus I R sin phi. So this comes out to be a rectangular form. Easier. Polar form to rectangular form is very much easier form, right? Now next. Also, if you have a particular, let's suppose you have x plus jy, you have a rectangular form. You can convert this into a polar form also. How you will convert this into a polar form? So first find out the magnitude, that will be under root x square plus y square. Then find out the angle, which is equal to tan inverse y by x. So I can write down z equal to under root of x square plus y square angle tan inverse y by x. This comes out to be a polar form. Okay? So rectangular form to polar form, you can convert it like this. Okay? Now why these forms are important? Because if you want to add or subtract two signals, that can only happen in a rectangular form. But if you're going for a multiplication and division, that can only happen in case of a polar form. That's why you need to understand how to convert one form into another form. So that can only happen using this concept. Understood? Yes or no? Understood this point? Yes or no? Okay. Now let's talk about how to draw the phasors. To find out leading and lagging between two angles. Achha, what is leading and lagging? What is the leading and lagging? Can anybody tell me? Leading means that one signal is getting, for example, signal X leads the signal Y. It means thus in a signal X, maxima occur before the signal Y. Similarly, if you say X lags the Y, it means in a signal X, maxima occur after Y. So leading and lagging depends on what you are actually observing, maxima or minima. Okay? Now how to identify whether two signals are how to identify which signal is leading and which is lagging? For that we are going to use this concept. This is known as the quadrant concept to understand the leading and lagging. What you need to do? You need to remember first of all quadrant here. This is plus cos, this is minus sine, this is minus cos, this is plus sine. This you need to remember. And next you need to remember for the positive angle, for the positive phase, we have an anti-clockwise rotation. For a negative phase, we have a clockwise rotation. So these 2 points you need to understand. Okay. Now let's draw a phasor here. Let's draw a random phasor here. For example, I have a signal X equal to 2 cos 10t minus 30 degree. 10t minus 30 degree. You need to remember this first of all. Now here you can see we have plus cos. We have a plus cos. So I will come to plus cos here. Now minus means clockwise. So I will rotate clockwise minus 30 degree. So here I have to rotate clockwise minus 30 degree. So this is the phasor. This is the phasor X. Or I can say the signal X. Now let's draw one more signal. Y equal to minus 3 sine 10t plus 30 degree. Okay? I'm going to draw this phasor. To understand, minus sign I have. So minus sign kahan gaya? Minus sign here. So we have a minus sign. Plus 30 means anti-clockwise rotation. So I will move 30 degree anti-clockwise rotation. anti-clockwise rotation 30 degree. This is a signal Y. Now let's suppose you need to find out phase angle, phase difference between these two. Let's suppose you need to find out phase difference between these two. How you can find out? See very carefully. Always remember, phasor rotate anti-clockwise. Always remember, phasor rotate anti-clockwise. So from the rotation, you can say that Y leads X. From the rotation, you can say Y leads X because Y is ahead of X. By how much angle? Just calculate this angle. Just calculate this angle. It is 30 plus 30, 60, 90, 150 by 150 degree. So 150 degree is the leading angle. 150 degree is the leading angle and Y leads X. Understand this concept of leading and lagging? Yes or no? This is the easier method to understand the leading and lagging concept. You first need to remember the quadrant, which is plus cos minus sine minus cos plus sine. Okay. Then plus angle means anti-clockwise rotation, minus means clockwise rotation. So when I need to draw minus 3 sine wala, so minus sine here, then plus 30 means anti-clockwise rotation. So I move anti-clockwise 30 degree. Okay? Same for the X. Now here you can see all phasors are rotate anti-clockwise. So since phasors are rotating anti-clockwise, you can see Y is ahead of X. Since Y is ahead of X, so I can say Y leads X by 150. How 150? Beta addition karo na. Addition karo na. Ye pura angle. This complete angle is how much? 30 plus 90 plus 30 equal to 150. Got it? Yes or no? Got it? Initial value. What is the meaning of initial value here, bacha? Means you are talking about this 2 or 3. You are talking about 2 or 3. Shivani, you are talking about 2 or 3 initial value. Are you talking about this or anything else? Because we are talking about signals now. Why we talk about initial value here? Although 2 or 3 means the length of phasors. For example, that 2 means the length of phasors. But when you are finding out leading and lagging, na, length of phasors does not use anywhere. Okay? So try to solve this question. Try to solve this. So calculate the phase angle between them and you have to state which sinusoid is leading. Let's see. Can you solve this one or not? Let's see, can you solve this one or not? देखो सिंपल है, कैसे करेंगे? Let's see, simple. First of all, remember this, plus cos minus sin minus cos plus sin. ठीक है? Simple, remember this. Now first we have signal V1 minus cos pair, minus cos plus 50, plus means anti-clockwise. So from here anti-clockwise will be this one. This angle is 50. Now V2 is 12 sign, positive sign. This is the positive sign. Plus 10 means anti-clockwise. So again anti-clockwise means here. V2 is here. Plus 10. Now phasors always rotate anti-clockwise. Phasors always rotate anti-clockwise. So here you can see V2 leads V1. Now you need to find out this angle. You need to find out this angle. What is this angle? This is 40. This much is 40, this is 10, so by 50 degree. Yes or no? 30 kahan se aaya? Meghna, tell me, how do you got 30? How do you got 30? How do you got 30? Rohit, you are just attending the session. You can watch the session from starting for a quality questions. And one more thing, beta, this is a revision session. It's not the session in which I'm going to discuss the different questions, because I have to discuss the theory part also, so that you have a complete revision. For questions, we already have multiple series going on for questions, and if you want to do some questions only. Okay, so understood? So this comes out to be how much? So this will be 50 degree. Good. Now let's talk about power. Let's talk about power quickly. We'll talk about the power in a very less amount of time, because many things about power you already know. Just a few points that you can get an extra question. Sir, take equivalent resistance question. Beta, I have already taken. You just need to watch our playlist. I have already taken the question on equivalent resistance. Not only YouTube, also on if you talk about app also. You know. So let's talk about real power. My fault. Active power. Symbol is P. Reactive power. Reactive power. Symbol is Q. And we have a apparent power. We have a apparent power where the symbol is S. Okay. Now be very careful. What is the active power? Always remember Vrms, Irms, cos phi in case of AC. Vrms, Irms, cos phi in case of AC. What is reactive power? Vrms, Irms, sin phi. Now, if you talk about apparent power, there are two things. One is the complex power. One is complex power. One is complex power. The complex power S is equal to V multiplied by I conjugate. V multiplied by I conjugate. This is the complex power V multiply I conjugate. I will share the link. Next, if you talk about apparent power, it is actually magnitude of S, which is Vrms, Irms. Okay, that point is important. Complex power and apparent power. Next, I can say what is cos phi. This is nothing but a power factor. This is power factor. You already know. Now, power. This flows from leading to lagging side. From leading to lagging side. Leading to lagging side. Q. This flows from higher potential to lower potential side. This flows from higher potential to lower potential side. Lower potential. Q also equal to I square multiplied by X, V square by X, whereas P also equal to I square R multiplied by V square R. Remember, this is RMS value. ठीक है? तो reactive power is across what? Reactive power is across the reactance, whereas active power is across the resistance. Okay. Now, if you talk about the complex power here, it is equal to P plus JQ. Complex power here is P plus JQ. Understand this point? Yes or no? Understand this point? Yes or no? One more point. Q is positive for lagging load, and it is negative for the leading load. For example, capacitor. If you have a capacitive load, then Q is negative. If you have a inductive load, then Q is positive. Okay, this is the apparent power. Okay, now that's next. What is the power triangle? Here you can see this is the power triangle, P, Q, and S, and this is the phase angle theta. Remember, what is theta? Theta, it is the phase angle. It is the phase angle difference. Between voltage and current. Okay, important point here. Okay, next you have this particular formula. These formulas are important. Just remember this formula. Nothing, it's very much easier. For example, what we have seen, that complex power is P plus JQ, Vrms, Irms conjugate. Okay. Now, if you find out apparent power, it is the magnitude of complex power. So, magnitude of complex power is P square plus Q square. Now, the real power is what? Real power means if you go to the power triangle, it is P, it is Q, it is S. So, what is the relation between S and P? They are linked by the cos phi. So, that's why P is equal to S multiplied by cos phi. Okay, understood? So, all of this thing you can remember. I told you this point also. Okay, let's try solving this question. Let's try to solve this question. Or is it, sir, it is the impedance angle. Let me discuss this point. What is the impedance angle? What is the power factor angle? Both are different things. Okay, let me discuss through one example. Let me discuss this one example. Okay, now understand this point. We have a AC circuit. We have a AC and DC मान लो. We have a AC circuit. We have a AC circuit. ठीक है? Where this is the VS phasor, IS phasor, V2 phasor. Okay. Now the load is Z2. The load is Z2. Now if I ask you what is the supply phase angle, if I ask you the supply power factor angle, then supply power factor angle is the angle of IS. It is the angle of IS and VS. The difference in the angle of IS and angle of VS. Remember this point. Whatever the angle difference between IS and VS, that is the supply power factor angle. If I say the load impedance angle, if I ask you what is the load impedance angle, now here I am taking this as a load. I am taking this as a load. Then load impedance angle here will be phi IS minus phi of V2. So both are different thing. Both are different thing. Okay, here I am taking a load here, the angle will be different. If we talk about a supply power factor, the angle will be different. Impedance angle will be equal to the power factor angle when there is only one load. For example, if I create this circuit, then impedance angle and also the power factor angle will be same. But when you have a multiple impedances connected, then the impedance angle different, power factor angle is different. Understood? Yes or no? Tell me this point. Do you understand this point? Here you can also say load impedance angle. Here you can also say load power factor angle. You can say it as a load power factor angle. Okay. So the best way to understand this point is that whenever you are going to find out a power factor angle, find out the angle between the voltage and current across that device or across that circuit. Okay. Now try to solve this question. Simple है. Simple question आते हैं. From a AC circuits, you are going to get a simple question. Why? Because now you have a virtual calci. In a virtual calci, it is very difficult to solve question based on AC. Because many things is not, you cannot solve many equations there. But earlier, when there was a manual calculator allowed, then the question was difficult. Because then you can solve the question using a calculator. But that is not possible in today's time. That's why the question from a AC circuits will be very much simple as compared to calculation. What will be the instantaneous current I1t? What will be the instantaneous current I1t? See very carefully. You can apply the KCL. So I can say I1 plus 5 angle 0 is equal to 10 angle 60 degree. I1 5 angle 0 equal to 10 angle 60 degree. Now what is? It is 10 angle 60 minus 5 because angle 0 minus 5. Now what you need to do? You need to convert the polar form into a rectangular form. So 10 cos 60 plus I sin 60 minus 5. तो cos 60 कितना हो गया 1/2 plus I root 3/2 minus 5. So it comes out to be 10 से 5 cancel. It comes out to be 5 root 3 iota, or I can say 5 root 3 angle 90, or I can say 5 root 3 angle 90. Yes or no? Simple calculation that you can do without calculator. Option A is the right answer. B नहीं आएगा. You are getting positive. There is minus 90. You are getting a iota 5 root 3. So option A is the right answer. Okay. Now try to solve this. Try to solve this question. 6.1 earthquake Afghanistan epicenter, sir, in Delhi NCR. I'm actually in Noida, but I haven't felt the earthquake. Nowadays, earthquake is very common in Delhi. For the circuit shown by how much the voltage across the inductor leads the voltage across the capacitor. Voltage across the inductor leads the voltage across the capacitor. See, this question we can solve by using a phasor diagram. This question we can solve by using a phasor diagram. But few things you need to remember. First of all, for a pure capacitor, current leads the voltage. For a pure leads the voltage by 90 degree. For a pure inductor, current lags the voltage by 90 degree. This point you need to remember. And for a resistor, voltage and current both are in same phase. So here you can see very carefully. Let me draw the phasor diagram here. First of all, this is capacitor, this is resistor. Both have a same voltage V. Enough? So I am going to take voltage as reference. I am going to take voltage as reference V. Enough? Now, what is the current passed through the capacitor? The current passed through the capacitor is IC. So this current leads the voltage by 90. So leading means anti-clockwise direction. So this leads the current, this leads the voltage by the angle 90. Enough? If you talk about IR, then in case of IR, voltage and current are in same phase. So this is going to be the IR. This is going to be the IR. Now see very carefully. What is the inductor current? Inductor current is equal to IC plus IR. Remember, this is the phasor sum. It is not the magnitude sum. It is a phasor sum. So when you add both of these, IC and IR, you will get this, which is IL phasor. You will get this, which is IL phasor. Yes or no? Yes or no? But what is the angle here? You are adding IC and IR now. You are adding IC and IR. So what is the angle here? It will be tan inverse XC by R. It will be tan inverse XC by R. Tan inverse XC by R, which means tan inverse 1 upon omega C R. तो ये कितना हो गया? Tan inverse. Omega is how much? Omega is 2. Capacitance is 0.5. 2 into 0.5. Resistance is 1. So it comes out to be 45 degree. So it means this angle is 45 degree. This angle is 45 degree. Now we need to find out inductor voltage. Now inductor voltage leads the inductor current by 90. Inductor voltage leads the inductor current by 90. So you have an inductor current. Inductor voltage leads the inductor current. Inductor voltage leads the inductor current by 90 degree. So this angle is 90 degree. This is 90. Now what you need to find out? You need to find out the voltage at inductor leads the voltage across the capacitor. So which voltage? Which angle? This angle you need to find out. कितना हो गया? 90 plus 45, 135. कितना हो गया? 90 plus 45, 135. 135. Understood this thing? So inductor voltage leads the capacitor voltage by 135 degree. Okay. So this is the phase angle formula. Also, you can also solve this question by finding out IC and IR, but that is not of any use. Because magnitude we don't require. I require the phase angle only. So phase angle I can solve by using a phasor diagram. Now try to solve. Okay. Now you can solve. Now I will do one thing. Since the time is up. So I will do one thing. I will send you the PDF. You can download the PDF from my Telegram channel. Okay, so you can get the PDF. But before ending a session, I will tell you one thing, that this is the QR code for the today's test. Okay, scan this QR code. Okay, scan this QR code after the class, or you can scan it right now. Here you can give the test on the marathon session that we have done today. So that you can get to know कि जो आपने अभी 5 hours invest करे, are you getting the return on that 5 hours or not? Also at 6 p.m. I have a class on app in which I am going to discuss the previous year question based on AC circuits and some more topics also. So you can join that class also on the app, correct, at 6 p.m. So don't forget about it. And if you have any doubt, you can join my Telegram channel and ask your doubts there. So tomorrow we are going to discuss question based on, tomorrow we are going to do revision based on the power system. So for all the electrical students right now, or those who will watch the recorded session, I will advise them कि watch a power system class or live. We will discuss each and every important topic there. Okay, understand? Okay, there are many topics which are not important for examination power system also. So we will discuss the important topics there. Also, we will solve 2 or 3 questions based on each topic so that the complete revision you can do it tomorrow only. Okay. So electrical से कौन से है? कौन है? Tell me who are from electrical. Who are from electrical? Tell me guys. Who are from electrical? Password नहीं है. I will give you the password free PDF. I will give you the password free PDF. There is no password. Okay. So we will end our session here. So all those electrical students join tomorrow at same timing 10 a.m. to discuss the power system. First we will start with the fault analysis. So miss mat karna subah class, because we will start with the fault analysis, not from the inductor. Okay. So bye guys. Take care.